All right, looks like we are live. Welcome everybody to Standing for Truth. My name is Donny and I am your host and moderator for tonight's Clash of the Titans debate between Mark Reid and TRock. These debaters are both very experienced at this point, and that means this is going to be a debate to remember. Gentlemen, TRock and Mark, thank you so much for giving us your time for this important debate. And what I like to do, though, before we get into the debate itself, is kind of break the ice, get to know you gentlemen a little bit before we start the fun. TRock, let's start with you. A little bit about yourself and how you doing tonight.
Might have to take yourself off mute, TRock.
Oh, TRock, I think you might be on mute.
There you go, buddy.
No, sorry, I was for whatever reason I keep forgetting. I had the videos opened in YouTube on a different web screen, and I was hearing both audios at the same time. Sorry. No, I've been good. Been very well. I can't complain at all. We've been blessed. I've just I've got kind of two quote unquote careers. I've got a full-time day job, and I've got a side gig that I do during the summer. It's not summer now, so that's slowed way down. I've just been working on some project stuff around the house, spending time with my son, that kind of thing. We've been sick here for the past week straight, though, so I'm kind of on the tail end of it, though, so I feel pretty decent today. Anyway, I'm looking forward to this discussion. I think we got some good evidence to bring forth and some good logical arguments, so just looking forward to it.
TRock, I appreciate that introduction. I hope the family gets better quickly, and I appreciate you giving us the time for this debate, even though you're kind of on the tail end of the sickness there. So for anybody that wants to see more from both debaters, I do have the relevant links in the description box. Mark Reid's channel, specifically TRock, doesn't necessarily have a channel, but I've got some links to a couple of his past debates for you to check out. So with that, Mark, good to have you back as well. Always a pleasure. How have you been? A little bit about yourself, a little bit about your channel.
Oh, thank you, Donny. Really good to be here. Yeah, I've been good. I'm Mark Reid. I actually am a student from Australia. I study computer systems and networking. I generally do this as a side gig, something fun to do. It is getting into summer over here, so it's kind of hot, and I do have a fan on. I hope it's not going to cause any problems, but if you do hear that, it's because it is really hot already, and it's probably going to get a lot hotter during the day, so I do apologize. But yeah, I basically do debate, I do discussions. My stance is scientific, my stance is atheistic, and I take a logical and rational approach to understanding everything, and my YouTube channel generally documents my stumbling through the YouTube world and just one person's experience from a secular point of view. But it's a pleasure to be here, and thank you so much, Donny, for being so very, very welcoming.
Well, I appreciate that, Mark. And again, to the audience, if you want to see more from the debaters tonight, Mark and TRock, please do check the description box for the relevant link. So what are we specifically debating tonight? It is the Great Age of the Earth debate. But the question that we are specifically engaging for tonight is, does physical evidence demand an ancient Earth? Mark would say yes. TRock would say no. And it's going to be a relatively formal debate. We're going to be starting with 12-minute opening statements, followed by 8 minutes of uninterrupted rebuttals. And then we're going to have a roughly 50-minute discussion. So we're going to keep this more free-flowing and organic rather than a real strict cross-exam where Mark and TRock can discuss the points of the debate. Then we'll have a 5-minute closing statement where the debaters can wrap up their thoughts and points. And then this is where we get you guys in the audience involved. We're going to have an audience Q&A, roughly 25 to 30 minutes. And so please make sure you're tagging me with your questions. You can tag me either at Standing For Truth or at Donny, just something that kind of jumps out so I don't miss it. And we'll make sure we have a good audience Q&A. So with that, we're just going to get right into it then. 12-minute opening statements. And Mark Reid, we're going to hand the floor over to you whenever you're ready and good to go. And I can share screens too.
Oh, fantastic. Thank you. I will just share this if you could be so kind, Donny. Really appreciate it. Thank you. Age of the Earth, or does the evidence demand an ancient Earth? Physical evidence demand an ancient Earth? As I've said, my name's Mark Reid. It is a pleasure to be here. I want to thank Donny for hosting, and I do want to just quickly take a second to say Donny has always been highly professional, highly inviting, highly welcoming, and I really want to thank him for that. And of course, TRock for being my erstwhile and of course current interlocutor. And of course, you, the audience, for giving me your time and hearing me out. I really do appreciate it. Firstly, I'll start by saying, and this is at the risk of being rude to my gracious host and my opponent, there is no scientific evidence for young Earth than there is for flat Earth. It has the same level of evidence for it. Now, I do realize there may be some flat Earthers out there who might be upset too. I hope TRock isn't a flat Earther as well, at the risk of sort of offending him. However, the fact of the matter is there's absolutely no credible scientific evidence to back up that the Earth is 6,000 to 10,000 years old. Unfortunately, we see the same sort of arguments from young Earth creationists as we do from flat Earthers, science denial, conspiracy theories, appeals to faith, claims that they have the quote-unquote real science. We see exactly the same thing from both, unfortunately. Generally, I'll be focused on two main areas for the age of the Earth. Firstly, there's radiometric dating methods, and secondly, ice core samples from the Arctic and Antarctic. Both are scientifically accepted and back each other up. I'll be showing how we know what we do about these topics, but not only that, I'll be showing why the young Earth creation model does not work for either of these. Firstly, let's go on to radiometric dating. So this is the simplest type of radiometric decay. It's radiocarbon decay. This is an unstable carbon-14 parent atom that through beta decay produces a nitrogen-14 daughter atom. Now, it's important to understand the half-life of these radioactive materials. For each radioactive material, there's a constant rate at which the atoms decay from the parent element to the daughter element. This rate is so reliable, we can base hyper-accurate atomic clocks on the decay rate of certain elements. And excuse me, I do apologize. While we cannot tell which atoms will decay, which individual atoms to decay, the half-life is the amount of time it takes for half the atoms in any given sample to decay into a daughter element, and it's incredibly consistent. In the case of my example here, this C14, this isn't very long. It's only about 5,730 years or so. After 11,460 years, only a quarter of the carbon will be left, and we can sort of see that here, the two half-lives passed. While radiocarbon dating can only date organics through, because that's the only thing with carbon in it, other methods are used to date the age of the Earth, which I'll sort of outline. This is just the simplest example I could give of radioactive decay. So this is a graph of the uranium fission track of decay, which goes through both alpha and beta decay. Alpha decay is when the nucleus ejects an alpha particle consisting of 2 protons and 2 neutrons, which is a helium nucleus. Beta decay can change a proton to a neutron or a neutron to a proton. Now, it's really important to note that all of this decay as it goes through from uranium to thorium to polonium to bismuth and eventually, well, to lead, bismuth, then lead. All of this results in a significant amount of energy output because it's throwing out things like neutrinos. The half-life for uranium-238 alone is about 4.5 billion years. So it's absolutely inconceivable that the Earth is young. There are other forms of nuclear decay, however, and we will focus on these. And we'll focus on the different types of radiometric dating that we have. And we can see radiocarbon on the top, accurate only to about 70,000 years or so. We can see uranium-238 here in the fission track. So it's much more useful when we're talking about the age of Earth to use something like uranium-238. However, the one that I really want to focus on are elements with a high half-life, but not so high as uranium-238. And the best one is potassium-argon dating here. This is potassium-40. It has a half-life of 1.25 billion years. Now, the reason why it's so good is because argon is a gas that doesn't naturally combine with other elements. It doesn't ordinarily combine. So what that means is we can be sure that there was no argon in the initial sample. Because even if it's, say, in a liquid with argon, the argon will not diffuse into the rock because it is an inert gas. So any argon found in that rock is going to be a fresh argon that has been locked in there from the decay of potassium. There are other methods such as uranium-234, which decays to thorium, and the fission track, which I mentioned earlier. This is a commonly used method to date rocks, as the decay rates of uranium are so well known, and we use multiple methods in order to corroborate one another, in order to make sure we've got the right date. Geologists also use other methods such as electron spin resonance here and thermoluminescence as this one. What they do is they rely on the accumulations of electrons in imperfections or traps in crystal structures of minerals that determine the age of rocks. It's completely different than radioactive decay. However, it absolutely produces comparable ages, even though the method is completely different. The last method of aging the Earth I want to mention is magnetostratigraphy. It relies on the orientation of magnetic metal particles reversing at times in the past when the magnetic polarity of the Earth's magnetic field has reversed. And I'll go into that further when we're looking at ice core samples. So, of course, these measuring methods only tell you when the rock was formed. They don't necessarily tell you the age of the Earth. So how do we tell? To find this out, we have to look at visitors to this planet. This is a rundown of radiometric dating tests we've done on various meteorites using the various different techniques. Now, the reason why we use meteorites is because they have not been subjected to any tectonic forces nor erosion by the atmosphere. So we know that they were formed with the rest of the solar system, including the Earth. Keep in mind, all these techniques use different radioactive elements, yet they all produce roughly the same age. And something like a 5 to 10% error margin is significant when you're talking about something that's 100 years old. But when you're talking about billions of years, that error margin isn't that significant. Add to this, samples from the moon have been tested that show the same age, as the moon doesn't have any tectonic activity or atmosphere either. What that shows is that meteorites, the moon, and the oldest rocks on Earth all formed at roughly the same time, giving us the age of the Earth when the solar system formed. It is important to note that these various analytical methods are used and they all support one another. None of these methods support a young Earth at all in any way. Multiple methods are used on the same samples and they produce consistent results. And that's something that young Earth creationists cannot seem to explain. Now, you could possibly argue the half-life of these elements was shorter in the past, but that creates a massive problem. The problem is that if radioactive decay rates in the past was faster and therefore the rocks were younger than what it seems to be, a lot more radiation from that radioactive decay has to happen in a much shorter time. Most of the heat from radioactive decay is produced by uranium-238, uranium-235, thorium-232, and our good friend potassium-40 that I was talking about with potassium argon dating before. This opens up a massive problem known as the decay heat problem. So if we take the half-life of these elements and reduce it to an average across all of the elements, say we average it out as a 500-year half-life instead of the millions or billions of years like in the case of uranium or potassium, it soon becomes evident that the heat buildup from radioactive decay, as well as the heat from the Earth's core, would cook the Earth completely. The above calculations is based upon an average half-life of 500 years for all radioactive materials, and the time frame is 6,000 years. So if we go back 6,000 years, the average surface temperature is about 65,000 degrees Celsius. And given basalt melts at about 1,200 Celsius, you're looking at a molten Earth 6,000 years ago. At the time of the Noah's flood, it would have been around 40,000 degrees Celsius per kilometer. And 2,000 years ago, Jesus could apparently stand temperatures of 400 degrees Celsius. So the whole idea that radioactive decay was in a different time frame just does not work. This is what it should look like when we have heat distribution for decay over a timeline, and that GA is giga-annum. It basically just means billions of years, or it's 4.5 billion years. The distribution of radioactive heat contribution to the Earth's internal heating should look like this, and it's consistent with the laws of physics and radiometric decay, while the young Earth model is not. Now, I would have liked to show calculations and graphs from a young Earth perspective on this, but they don't actually have any. I did find notation from the RATE project, which is the Radioactivity Age of the Earth. It's a creationist group, and they essentially appealed to some unknown yet undiscovered or some mechanism that we're just unaware of to solve the problem, and acknowledged it was a problem for the young Earth creationist model. Not to put them on the spot, but maybe TRock can give us the calculations required to make it work today and rewrite physics, maybe. We're just going to have to see, I suppose. Many different types of analysis, and I'm going to go into ice cores here. Many analysis is done on ice cores, including visual layer counting, tests for electrical conductivity and physical properties, and analysis for inclusion of gases, particularly radionucleotides, and various molecular species. Simplest approach, count the ice layers. Other approaches can be used, like modeling ice accumulation and flow, or correlation nucleotides, or trace atmospheric gas with other timescales, such as periodicities in the Earth's orbital parameters. And that's Milankovitch cycles. I will talk about that later. In cases where volcanic tephra is interspersed with ice, it can be used for argon-argon dating, and it can be used to provide fixed points for dating the ice. This is an ice core taken from an ice sheet on the west side of Antarctica. Note the dark banding that occurs in one of the layers of this sample. This is a layer of ash that settled on the ice sheet, and we can tell due to the annual thawing in summer and refreezing that the ashfall happened 21,000 years ago. Markers like this allow us to track where different samples match up, and we can track these and match the samples up, establishing where they fall within the year, or the timeline, I should say. We can also synchronize Arctic and Antarctic ice cores via events like the Leschamp event, which is a geomagnetic reversal, a reversal of the Earth's magnetic poles, which happened about 40,000 years ago. This can be identified in the ice core samples. The ice core samples are broken up like this into manageable sections, but the longest of which are 3 kilometers long and go back about 800,000 years. Now, they're kept in very organized storage because we don't want to lose track of which sequence they fall in as we track backwards in time. Now, this is a sample from the GISP2, which reached bedrock at about 3,053 meters, or 3 kilometers. But the ice core sample itself is 2.8 kilometers in length, and that was done in Greenland. And that's the Greenland Ice Sheet Project. The lower section of the ice is dated at 110,000 years before present, and this sample is illuminated by a fiber optic source, so it doesn't look like this, it's just been illuminated. We can tell by the banding that occurs that the ice within the light sections indicated the summer layers, while the ice melt has occurred, and the dark sections are the winter layers where no ice melt has occurred. And in this way, we can sort of trace back. We can also trace the changes in temperature through Thank you. Eccentricity in the Earth's orbit. We can sample the air bubbles trapped in the ice. And we can tell the rise and fall of temperature due to Milankovitch cycles. Now, Milankovitch cycles are variation in the orbit where it sort of wobbles. Just like with this one, we can sort of tell from the Earth's wobble, and it lines up exactly with the temperature in the ice core samples. So not only can we see the temperature of summer and winter, we can also see these Milankovitch cycles on the glacial atmospheric readings taken from the ice core samples. This is how we know with no doubt whatsoever that the Earth is old, as these samples can be correlated back to 800,000 years. Admittedly, that's not the 4.5 billion years old that the Earth is, but I am sorry to say that a young Earth is not true. It is just I realize I do apologize, but it's just a dream of people that believe a holy book over reality. Thank you.
Thank you, Mark, for that opening statement. I do appreciate the visuals and the points that were clear and concise. This is definitely going to be an excellent debate. So with that, I like to be a little more easy going on the opening statements, especially with debate topics this heavy. And so to be fair, TRock, we will give you equal time, let's say between 14 and 15 minutes. And whenever you're ready, the floor is yours. If you need me to share a screen, let me know. And
I will be sharing screen. Is my audio coming in okay?
yes, sounds great.
Okay, because you started roboting a little bit there for a second. Okay, yeah. Share screen. Give me a second.
Your camera is coming in a little laggy, so there might be a slight connection issue on your end, TRock, but we can still see and hear you enough that it's certainly okay.
Okay, that may get me into trouble though on presentation because I have a tendency to move ahead slides before people can see them.
Okay, slides are up, and you look like you're coming in good still, even with the slides up. So
okay,
you might be fine.
Good deal. Okay, does physical evidence demand an ancient Earth? To say yes implies that no evidence exists that could be construed to mean the Earth is young, as in my version of young, 10,000 years or less. Side note, real quick, my personal position is the Earth is about 6,000 years, plus or minus 200. But saying yes to the question at hand also implies that any evidence that does appear to mean the Earth is young must be contradicted by real-world physics. Okay, so there are types of data that can be construed as, scientific information, and those are measured, i.e. what you can directly measure. There is observed characteristics, and then there is inferred or calculated data. So what can be measured? Things like weight, length, width, height, density, temperature, hardness, ductility. Those things can be directly measured. What is observed? Things like color, location, relative size, relative direction. Those are the types of things you observe without, quote unquote, measuring them. You simply observe and describe them. And then what is inferred or calculated? Specific unseen events of the past, age, specific quantified amount of time passed, processes that can't be replicated or observed, and averages. And I've got a little side note in here that I think is kind of important. Rates applied to deep time are actually averages of sorts. And I'll explain more on that later if need be. What evidences appear to support an ancient Earth? This was brought up by Mark during his presentation. Radiometric dating. There is lead, rubidium, strontium, uranium, lead, neodymium, samarium, potassium, argon, those types of radiometric dating. Ice cores, as he's mentioned, things he did not get into too much. VARVs, he did mention fission track dating, and then of course geological time, actual geological formation processes that supposedly cover deep time. What evidences appear to support a young Earth? It's a long list, to be honest with you. There's a low racemization of amino acids in fossils, which I've got numbers. By the way, those numbers you see to the right of the screen in column 2, those are they're basically, by and large, mostly my numbers, not necessarily creation science community's numbers. In some cases they are, but I'll defend any of them on my own grounds. Okay, other evidences to support a young Earth: rapid magnetic reversals, Australia's burning mountain of coal, planetary magnetic fields, Earth's magnetic field, human population, animal population, helium abundance in zircons, Y chromosome mutation rates. That's a pretty long list. I'm not going to read every single thing in here. I'll probably zero in real quick on the ones that I think make some of the best arguments. This one right here, Earth's magnetic field, is one of the strongest, most difficult arguments to get around. Abundance of C14 in the world, no matter where you go and no matter what the source is. Another favorite of mine, I think, is down here towards the bottom. Lunar recession is a major problem for standard physics in an old Earth model. There are many others, though. ocean salinity, faint young sun paradox, methane on Titan, subducted slab temperatures, rate of heat loss from the Earth, fulgurites, erosion rates are another big favorite of mine. I've got them listed twice, once for horizontal, once for vertical. One pertains to, say, mountain deconstruction, and the other one pertains to coastal erosion kind of things. So in that, I'm gonna follow some of the path that Mark followed on the Age of the Earth. This is what you're seeing here. There's a book called The Age of the Earth by a man named G. Brent Dalrymple. He's an old age advocate, presumably, Big Bang and the whole secular view on origins. And so he basically, the short story behind this book is that he was caught up in, he was invited to be a witness in some legal cases in some trials pertaining to teaching of evolution or teaching of creation in a public school environment. And what he noted was that there were not any books in existence that really explained the age of the Earth in the secular sense, in solid scientific terms that a layman could understand. So he wrote this book, and he comes highly recommended by a lot of people. This particular screen, what I'm showing you here, is the review on this particular website, sup.org books. And they basically give him props and say this is a definitive, masterly history and synthesis of all that has been said by theologians and scientists and is known to science about the question, how old is the Earth? It explains in simple and straightforward way the evidence and logic that have led scientists to conclude that the Earth and the other parts of the solar system are not several thousand years old, as some today would have it, but 4.5 billion years old. Okay, and I'm not going to read the whole thing here. What I did was went back and looked at Dr. Andrew Snelling's review of this book to basically zero in on some of Dalrymple's key arguments about why he believes the Earth is 4.5 billion years and why young Earth creationists believe that he is simply mistaken. Here's another endorsement for Dalrymple. It says, Dalrymple authoritatively unfolds the evidence for an Earth that is billions of years old. So obviously this is quite pro ancient Earth material here. What I've got though is I'll make sure I pull up the right document here. This is actually Andrew Snelling's review of the book, The Age of the Earth. And some interesting things that Dalrymple tries to do. It says, according to Dalrymple and his colleagues, the first 700 millions of the Earth's history has been effectively erased, which means the oldest rocks you could, quote unquote, reliably radiometric date are about 3.8 billion years old. And the oldest rocks found on Earth are thus not nearly as old as the Earth itself. Okay. Some of the key evidence for the age of the Earth, Dalrymple says, comes from bodies in the solar system that are not so highly evolved as the Earth. Of course, I got to ask Dalrymple, how do you know they're not so highly evolved as the Earth? And actually, this kind of comes out throughout this review. We'll see some of his thinking here. Uranium, lead. So basically, Mark brought this up. Dalrymple, his review basically points to these meteorites and or lunar rocks. So the whole point is that they, and this, to me, this is really a key to the whole debate of whether or not you can rely on radiometric dating at all. He had to have some sort of geological context that he already believed to be true in order to justify using them as his basis for radiometric dating of the rocks and by extension the Earth and the solar system. So the geological context was that they didn't come from Earth. They weren't affected by Earth's history. They came from external to the Earth. Therefore, they have their own history that had to have preceded the Earth. But of course, that's question begging. How does he know where they came from? He has no idea. One of my biggest complaints with radiometric dating in general is neither Dalrymple nor any other geophysicist or astrophysicist can tell you where any of the heavy elements come from, not one single one of them. So what Dalrymple is doing here is he is using this uranium lead or lead, but he says uranium lead discordia data from zircons and whole rock, rubidium, strontium, lutetium, hafnium, and lead data, all from the Amixoc gneiss, all consistently give a presumed emplacement age of 3.7 billion years or more, and a probable age of initial metamorphism of about 3.6 to 3.65 billion years. But individual krypton-argon and argon-argon ages on minerals, biotite, hornblende, and muscovite within the same Amixoc gneiss are inconsistent, ranging from 1.67 billion years to 4.85 billion years older than the Earth itself. While uranium, thorium, lead, and rubidium, strontium measurements on a variety of separated minerals also show a confusing pattern rather than the straightforward isochron relationships of the whole rock data. In other words, this idea of concordant dates or cross-confirming methods and samples, it's not nearly as concrete as what we're often led to believe. Absolutely critical is what constitutes primordial lead. See this little deal I got right here, piece de resistance. That's actually a reference to I guess Dalrymple's what he believes to be the centerpiece of the discussion that actually demonstrates that the Earth is 4.5 billion years old. But it all has to do with this primordial lead. And whether this is represented by the lead isotopic compositions of iron meteorites, such as the Canyon Diablo. So the problem with these extraterrestrial rocks is that they give, in some cases, excessively long ages. And so what happens is they've got too much daughter element in them. And so Dalrymple and other scientists basically just try to explain that away by saying, oh, it's primordial. In other words, it's one of those rare rock samples where in its initial formation, it already had lead in it. So in other words, the decay doesn't start from 100% parent, 0% daughter. It starts from, some, I'm just making numbers up here, 80% parent, 20% daughter or whatever. And then radiometric decay proceeds from there, just adding to existing lead. So you have to correct for whatever percentage of pre-existing, the term here, primordial lead, is believed to have been in there. But it's all question begging because you have no earthly way of telling the difference between what he's calling primordial lead and what's 100% from in situ decay. So it is fascinating, therefore, to read Dalrymple's comments that the uranium lead method has proven of minimal value in determining the ages of individual lunar rocks, because most uranium lead isotopic data for lunar rocks, when plotted for the conventional lead uranium versus it's lead 206 uranium 238 versus lead 207 uranium 235 Concordia diagram, are highly discordant and do not fall on Concordia. Says Dalrymple. Dalrymple says that the reason for this is that most lunar samples contain initial lead. That's the primordial lead. How does he know that? He doesn't. There are some isotopic considerations that are probably made to try and come up with this explanation, but the reality is you can't tell the difference. Interesting note about both uranium and lead is that they migrate in water fairly readily. Not to mention they combine with other minerals such as copper. And therefore, if it has very much geological history to it, if it has been under heat for any length of time, migration is extreme migration even should be a given. And the ultimate method, as far as the topic of this book is concerned, is the lead-lead isochron method, which he says is the basis for what is thought to be the most precise value for the age of the meteorites and the Earth. I've done a complete series on specifically isochron dating, and isochron dating is not what these guys make it out to be. Isochron dating relies on having a parent, a daughter, and an isotopic variation of the daughter that's
1 minute.
Got it. Thank you. Isotopic variation of the daughter that's non-radiogenic. And so what you're looking for is that the two different ratios combined to plot out a line that in and of itself is actually pretty misleading. So I'm going to stop here on the radiometric portion of it. I also looked at some of the ice core information that Mark alluded to. Happened to look at the same two things. Ice core data is not what it's made out to be either. Those layers are considered annual layers, but the reality is we have known examples where those same layers exist in the thousands, literally in the thousands of quote unquote annual layers that we know were formed in 30, 40, 50 years. So with that, I will yield my time.
Okay, TRock, thank you for that roughly 14 to 15 minute opening statement. Gentlemen, that concludes the opening statements. Great job and great work to the both of you. Appreciate the visuals and the work put into this debate so far. So here we go. We're going to hand it back to Mark. Mark Reid, you've got let's say up to 10 minutes for a rebuttal. And whenever you're ready, the floor is yours.
Okay, thank you, Donny. Thank you very much. So all of this evidence, and TRock did skim through a lot, so I'll try and cover whatever I can. But there's too much to go through just all in 10 minutes. So all of these are young Earth sort of arguments and talking points, and I get that, but none of them have actually been scientifically accepted. None of them have any real scientific backing. They're more just justifications of a prior position, which is that the Earth is young because it's based upon a faith statement. Just some of the things that he went through were sort of lunar recession. That assumes that this rate of recession of the moon is consistent, whereas if the moon was closer, the rate of recession would be lower because the gravity would be higher, because gravity works upon distance to the object. So a lot of these are based upon misconceptions. You sort of skimmed over ice cores, and I'd love to get into that later on, but you sort of skimmed over it. Dalrymple and the Age of the Earth, he sort of said there's no books to explain this, and he's kind of right. This is the purview of geologists, and I want to make it clear, I'm not a geologist or a physicist. There are people that understand this way better for me. I'm simply communicating to you my understanding of these subjects, but they understand it way better than me, and they understand it way better than TRock. And the scientific consensus is that the Earth is 4.5 billion years old, and that is something that people like Snelling are in extreme opposition to, and really they're not really taken with any kind of seriousness in their field. The reason why is because that Snelling was part of a rate project for the Institution Creation organization that basically said up front their reasoning was that the Bible says that the Earth is young. That was their main reasoning to it. And that rate project has a number of problems, including the heat decay problem I mentioned, the decay heat problem rather, that I mentioned earlier. And they acknowledge this, that they've got massive problems in this field. And TRock mentioned highly evolved. What do you mean by highly evolved? As far as I understand it, highly evolved means that the planet has a high level of tectonic activity and erosion and other forces that other planets do not have. For instance, if we're looking at other planets, they may not have an atmosphere, so they do not have the same forces acting upon them, and that's simply what they mean. So this whole idea of what does highly evolved mean? Tectonic activity and atmospheric conditions that would cause the rocks to change, essentially. One of the things that he noted was sort of the isochron discordance, which is a known problem. So the ranges within sort of, say, potassium argon dating vary. We're aware of this, and basically it comes from having different concentrations of radioactive material in different parts of the environment. We can plot the isotope concentrations of all of these minerals, and geochronologists can find the age of the rocks. They can also be improved, the accuracy, by using several different radioisotopes, and that's where we overlap multiple different methods to come out with the correct age. And this is what TRock wants to skip. He wants to focus on one thing at a time, not realizing that we're using multiple methods for the same sample. or the same rock, basically. Now, that can the isochron discordances can lead to a 10 to 15% error bar that it can vary within. However, that's a far cry from a error ratio of 1 million that he's trying to claim, because if it's over 1 million, because if it's 4.5 billion years old and he's claiming 10,000, that is a far higher error rating than what he is pointing out in that paper. In fact, it said it varied from 1.6 gigaannum to 4.5 gigaannum. And now that's a huge rate, but that's not anywhere near 10,000. He doesn't have any evidence for 10,000. All that he's trying to do is point out problems with dating that they've already solved by using various methods to compensate for those dating inaccuracies. This doesn't get him to 10,000 years. It doesn't get him close to 10,000 years. So we claim that we don't know where the rocks came from. We do know where meteorites came from. We do know where moon rocks came from. Essentially, we know where these rocks came from. What we don't know is when the rocks were formed. And that's why you get some rocks that are 1.67 gigaannum. Because if that rock metamorphosed in 3 billion years after the Earth formed, that is the date we're going to get. Because just because you measure a rock, and this is what TRock doesn't seem to understand, that if you measure a rock, it's not telling you the age of the Earth. It is telling you when the rock formed. That does not necessarily mean that it was formed when the Earth was formed. For that, we have to get the oldest rocks, and which matches the meteorite data, which matches the moon data, because don't forget, they don't have tectonic activity. So they were formed when the Earth was formed. And the whole thing is that Snelling, his arguments have been debunked. He hasn't produced a paper supporting this. His research methods have been dubious and criticized heavily by the rest of the geology community. He really is not a leading figure in the geology scientific community. He isn't a figure really at all. He is a leading figure in arguing for the Bible. That's all. He does not have the scientific chops it needs to make these arguments. So he hasn't addressed potassium argon, and that's one that we do use mostly and then back up with other methods. He hasn't explained why these methods all overlapped. If it's so inaccurate, why do the dates all overlap? Lead, even though we can't date individual lunar rocks, we can use multiple rocks to assess the age of that geological structure. So when it says we can't date individual rocks, it doesn't mean we can't date the moon at all. It just means we need to use other methods in order to provide that dating. But TRock obviously wants to skip all of that. He wants to skip the correlations between multiple dating methods and say, hey, we got a result we didn't expect at this point. It still doesn't make the Earth 10,000 years. Nothing that he said in his opening demonstrated any physical evidence that the Earth is 10,000 years old. And I just want to point out that evidence, you can always find evidence, because basically he said, what we want is good evidence and physical evidence. Evidence can be stories, and evidence can be anecdotes. We want solid, scientifically verified physical evidence in order to back up your claims, which TRock has not provided. Thank you.
Okay, Mark, thank you so much for that rebuttal. And now we're going to hand it to TRock. TRock, whenever you're ready, you have an uninterrupted rebuttal as well. And again, let's say up to 10 minutes. So TRock, whenever you're ready.
Is my audio still coming in good?
Yes. Yep.
Okay, good deal. I am going to share again.
Okay, I'll start the timer when you've got the screen up and shared. I don't see it in the corner just yet. As you get that going, TRock, I will remind the audience that I am taking questions. I'm all up to date on the questions currently. So just make sure to keep it on topic as much as possible. For anybody just joining us, the topic we are debating tonight. Does physical evidence demand an ancient Earth? And there you go, TRock. I see the screen is shared, so go ahead.
Okay, so I mentioned before, I've done a complete presentation specifically on isochron dating and why it just does not work. It is not a dating method at all. And so Mark made the comment that we understand that there are some discordant data that we've addressed, and then he talked about some of the error bars, how they can move up and down and that sort of thing. But none of that actually describes the problem with isochron. This describes the problem with isochron. There is a laundry list of words that tell us specifically that isochrons do not yield dates. There are, and these are in the open literature, in the scientific literature, there's pseudo-isochron, apparent isochron, false isochron, mantle isochron, secondary isochron, mixing line or mixing isochron. To me, that's probably the most telling word in the group. Erupted isochron, inherited isochron, source isochron. Those words come from the fact that secular scientists have identified isochron plots all over the planet. And this is 11 different terms, meaning that they come from a variety of individuals, not one or two individuals coming up with a bunch of different ways to say the same thing. All over the planet, they have found quote unquote isochron plots that they obviously don't agree with and think that it is not actually rendering an age correctly from it. And that mixing, that number 6 on there, mixing line or mixing isochron, that basically, see if I can do this here, is this problem right here. It's literally just a physical mixture, nothing else. You can literally grab any 4 substances on the planet. If you can, you want something kind of fine grained, obviously, but all you do is mix them up and you will get an isochron plot. You can do this through numeric simulations. You can do it through physical simulations. It does not matter. You can just mix stuff up and you can get an isochron plot simply because they just represent the mixture in which those particular elements appear, or isotopes, as it were, in radiometric dating. Now, I will agree with Mark. It is incumbent on me to provide some evidence of why I believe the Earth is young. And going back to this first statement up here, no evidence exists that could be construed to mean the Earth is young, and any evidence that does appear to me to mean the Earth is young must be contradicted by real-world physics. And so insert half-life calculations for Earth's magnetic field. The Earth's magnetic field, just like radiometric dating, has a quote-unquote half-life, just like radiogenic isotopes have a half-life. Earth's magnetic field also has a high half-life, and it happens to be extremely short. It's 1,400 years, which is really, really slow. So what you're seeing here, years before present, in this column right here, I'm going to zoom that up a little bit so that we can kind of bring the focus to this. Years before present, relative amount increased in the Earth's magnetic field and the number of half-lives passed. So go back 1,400 years and you've got 1 half-life, and this column right here shows you its relative strength compared to today. So it's twice the strength 1,400 years ago, if this 1,400-year half-life is true. Go back 2,800 years and it's 4 times as strong. Go back 4,200 years and it's 8 times as strong. Well, right here, this is highlighted yellow because this is roughly matches the biblical timeline. Assuming a consistent 1,400-year half-life for the history of the Earth, that would put the magnetic field strength of the Earth at creation week about 19 times stronger than it is today. That's pretty stout. But go back just 10,000 years, and it's 152 times the strength that it is today. Now, I'm going to go down one more time. Here, 20,300 years ago, it's 23,170 times the strength of today's magnetic field. That's ridiculous. That would rip all the iron out of your body. That would kill every living thing on the planet. Nothing would survive. Now, what's the problem with these two time frames, 20,000 and 10,000 both? Neither one of them represent the time of the last supposed reversal. So what secular scientists are banking on is that these reversals constantly keep the Earth's magnetic field not just below a certain level, but also above a certain level. In other words, it has to stay within a relatively narrow band for life to exist on Earth consistently for 4.5 billion years. Nothing about the magnetic decay process suggests that anything about that is realistic. And so if you do the math and you see how many reversals, because what I'm supposing is the Earth won't stand making it much past about 8,400 years without a reversal to correct the magnetic field. And so if you take that number and divide it into the, we'll use 3 billion years, since that's roughly what many secular scientists believe the origin of life began about 3 billion years ago. But if you do the math on that, and we can do that real quick, equals 3 billion divided by 8,400. That means you have to have 357,000 reversals to keep the Earth's magnetic field in check so that life can exist on Earth. There's nothing realistic about it. Nobody's found that many reversals in the so-called rock record. It's just unrealistic. There is no mechanism to do that, because part of the problem is that every time you have a reversal, you decrease, you accelerate the decrease or the decline of the magnetic field strength as a whole. And something has to exist to pump it back up. And so in secular science, some have posited these ideas, hypotheses. They're not theories, they're not tested, they're not anything. They're literally just ideas thrown out there in the open literature, that the Earth has a so-called dynamo effect, but it has to do with what they call differential rotation of the core, which means the core rotates differently than the external, the outer shell of the Earth, in order to produce this alleged dynamo effect. But the problem is that it's kind of like if you hold a bucket of water in your hand and you spin it in an upright position, in a horizontal plane, so that you're not trying to spill the water or anything. You're just making the water spin in the bucket. As soon as you stop spinning the bucket, it only takes a few seconds and the water stops going in circles. In other words, liquid loses its momentum really quickly. So if the Earth ever had a differentially rotating core, kind of like the sun does, it wouldn't last very long. Wouldn't last very long at all. And so for me, this concept of a declining magnetic field, and this is based, just to be perfectly clear, the declining magnetic field is based on a physics that's associated with electromagnetics. So things like circuits are use the same basic concept. There's a half-life formula that looks in somewhat similar to how you do half-life formulas for
2 minutes
radioactive elements. Anyway, you use the same exact concept when you're calculating values in circuitry, in electronics. It's very well known. It's very well tested. It's well understood. There's nothing hokey about it. We're not applying some different kind of physics. It's exactly what you expect the Earth's core to do. As massive as it is, it still has a known decay rate for its magnetic field, and it's been measured for about 200 years now. And it's been shown consistently to have a steadily declining magnetic field. So there's no way in the world you can get the Earth older than 10,000 years, much less 4.5 billion years. And I'll yield my time right there.
Okay. TRock, that concludes your up to 10-minute rebuttal. That concludes the opening statements and the rebuttals for this epic debate. So these two experienced debaters here, Mark and TRock, they are coming in swinging. They've put in the work, and they're both bringing up some fantastic points. So we've got a lot of points, therefore, to discuss for the 50-minute discussion portion. With that, TRock just ended with his rebuttal. And so, Mark, why don't we allow you to start us off here in the discussion with the first topic? Gentlemen.
Sure. Thank you so much, Donny. I really appreciate it. I don't know where you got that idea that there's a half-life to magnetic reversals, because there's no half-life to it. On average, full magnetic reversals are every 450,000 years, but that's an average. The last full magnetic reversal was the Brohi's Matayama reversal, which was 780,000 years ago. So I have got no idea where you are getting these information from. In fact, you might be talking about magnetic excursions like the Lacham event, but they're not full magnetic reversals. So nothing you've said applies to it. And sort of that event was I believe 41,000 years ago. So I don't know where you're getting this information from, TRock. Maybe you can cite me and show where for a start, magnetic reversals of the Earth have a half-life, because as far as I'm aware, they don't. They happen at random intervals, on average in a certain time frame. And maybe you can cite me where you're getting that it cannot be older than 10,000 years, because we've only seen 183 reversals over the last 83 million years.
Just to be clear, I did not say that the reversals have a half-life. What I said was the Earth's magnetic field strength has a half-life. And this is true for all non-permanent magnets. It's true for permanent magnets too, but it's true for all magnetic bodies that the magnetic field strength itself has a half-life. And what I've cited is 1,400 years for that half-life. Where is that derived from? It's derived, I alluded to it, it's derived from standard physics. So there is actually a decay formula, like I said, just it's very akin to what you would use for radiometric decay, where it looks something like e to the negative kt, where k is a decay constant, t is time, and so it's based on the natural number e. That's why it's an exponential decay. But it's actually calculated. That 1,400 years is calculated from the known measurements over what I alluded to the past couple centuries, where people have consistently measured the Earth's magnetic field strength, and they've noted the decline at something to the effect of about 5% per 100 years. But you can plot it, of course, like I said, because they've been doing it consistently for a couple hundred years. It takes 100 years to recognize that full 5% in its entirety, but you can see the decay over time and just mathematically convert it to a 1,400-year half-life. So reversals in the apparent reversals that you're citing at 700,000 years or whatever number you put out there, you're question begging. How do you know how many years went by since that reversal?
Yeah, so as I said earlier, we can count through to the ice core samples, where we can see them laid down, and we can mark certain events in them to line up with other samples. So there's a lot of data on that. Now, for an ordinary magnetic field, you may be right, but Earth doesn't have just a magnetic field. It has a solid iron core surrounded by a liquid layer, which creates sort of a dynamo effect, which doesn't mean that you can apply a half-life to it. That isn't what happens. The magnetic strength of the field varies, but it isn't a linear progression downwards. I'm really sorry, TRock, but you're going to have to provide some scientific data on that, because to me, that's just an empty claim saying, hey, I'm going to treat the Earth like, your standard fridge magnet, and say that the magnetic field will decay. And this is the half-life for it of what I've calculated. I'm really sorry, mate, but the Earth is not a fridge magnet. It has a core that is rotating, that is creating a magnetic force. It is a different thing than what you are thinking of. So as far as I'm concerned, that is just a hollow claim. And we can see the reversals, multiple ones in rocks. Like we can see where the 183 reversals have occurred. So it's not like we don't know this has happened. We can see these reversals occur and the strength of them, how long they lasted. We can see all of this backed up by peer-reviewed science, backed up by radiometric dating, backed up by ice core samples, and backed up by other, like stratigraphy and things like that.
So you use some terminology there that shows that either you don't really understand the argument, or I'm not sure if you're, I seriously doubt you're trying to misrepresent my argument, but I'm not sure you totally understand what I've been saying. You said the magnetic field decline is not a linear downward progression. I said the exact opposite. It's not linear. It's exponential. The formula is literally, like I've said twice now, it's literally akin to what you use for radiometric dating. That's exponential, not linear. And that is a big part of the problem. That means the further you go back in time, the faster the acceleration was, or would be in a doubling or a half-life scenario. But not a fridge magnet, agreed, but it's kind of worse than a fridge magnet would be. A fridge magnet would be much more stable. The dynamo idea sounds good on paper. It's much more of a theory than it is, or much more of a hypothesis or an idea thrown around in the literature than it is a testable theory. The problem with the dynamo idea is that, like I've already said, that actually would accelerate the rate of decay of the Earth's magnetic field. It would not stabilize it in any way. If you take a regular iron magnet and drop it on the ground, you will disrupt its magnetic field and cause it to decline faster than if you just let it sit still. If you heat it up, you'll cause the decline of the magnetic field of that iron magnet to be even faster than if you just left it alone at a standard temperature. Nobody's debating whether or not reversals have happened. Everybody in creation science agrees that reversals are apparent in the rock record. That's not actually up for contention in any way. It's those very reversals. Number one, they don't happen frequent enough to give you this very consistent bandwidth of a tenable magnetic field strength for life to exist on Earth. That's one of the problems. You don't have enough of them. And the other problem, of course, is there is no alleged dynamo. The Earth is spinning around. Any quote unquote dynamo would basically stabilize and normalize, just like my example of a pail of water spinning in a circle. It would normalize very quickly. 4.5 billion years is way too long of a timeline to expect a dynamo to continue in a free spinning body.
Well, you've said a lot there with nothing to back it up. I asked sort of a citation on this idea that the Earth cannot, like, while its magnetic field does vary, it does decay. When the Earth magnetic flip happens, it does get stronger as well. And I can point to papers where we can see that in the rock's record, because we can see the effect of, and you agree, we can see the effect of the the magnetic field of the Earth on these ferrous metals in the rock. You have agreed that that is the case. So why is it that all of science disagrees with what you're saying, and that they say, hey, the Earth does have a dynamo effect. Here is how it works. Solid iron core, liquid outer core. This creates the dynamo effect that powers our magnetic field. But you want to overturn all of physics and all of science and say, hey, because of your belief in the Bible, this cannot possibly be true. Do you have a single scientifically valid citation to back up these claims that you are making?
Do I? Yes, I can get you some scientific citations, but I want you to back up too on something that you said. You said I'm contradicting all of known science.
Yes.
No, this dynamo thing, the problem with the whole idea is that barring the water in the oceans, and technically including the water in the oceans, every single inch of the Earth is moving at the same angular velocity, which means where its position out in space, where it's rotating on its own axis, that means that the angular velocity at the core is the same as it is at the crust. It's X number of degrees per minute, per month, however you want to quantify it. The velocity is not different for the mantle than it is the iron core. That's what it would take to have a dynamo. You would have to have the core has a different angular velocity than the mantle does, or the crust. That doesn't exist. You don't have a scientific source that says that's what the Earth is actually doing. It's not.
Okay.
There are some opinions in the literature that a dynamo might explain variations in, and another.
What generates the magnetic field? Okay, sure.
Another real quick point that you probably need to acknowledge is that when you talk about a reversal and how it basically augments the strength of the magnetic field, which is your belief, right? Is that accurate?
Sorry, the augments.
A reversal of the magnetic field augments the magnetic field strength.
Yeah, so
Yes.
if you're talking about a reversal, it's basically going to wind down and then reverse and wind back up. That's essentially what happens. So I've got a paper here from Cambridge University Press, Temptations of Theory, Strategies of Evidence, Blackett and the Earth's Magnetism. But I do want to ask you, what causes the Earth's magnetic field then? If it is not the interaction of the solid core, inner core, and magma outer core, what actually causes it, TRock? Why is the Earth magnetic at all?
Well, largely because it's iron. And so Humphreys, Dr. Russell Humphreys, real quick before I get in, I'm glad to get into that because that's a really good point, and I really do want to get into that. But I want to bring out this one point about the whole reversal thing and how it plays to the field strength. And you made this mention, and I know it's in the literature, and I don't even disagree with the fact that the reversals actually augment the field strength in some way. The problem is that it doesn't. You haven't acknowledged that a reversal can increase the field strength in what's called, so they're basically what they call bipolar and non-bipolar field magnetic fields in the Earth. Bipolar is how you think of a normal magnetic field, a north and a south pole. So that's why it's called bipolar, 2 poles. But there's as many as 8 polarities in the magnetic field of the Earth. And so what happens is the vast majority of the field strength is contained in the bipolar magnetism, not in the non-bipolar. And so what that means is that the temporary increases that you see, they're actually in the non-bipolar, and they represent a very low percentage of the total energy. The net energy goes down over time, which is what the past 200 years of actual scientific data show. That's what I'm saying is what can be directly measured, not inferred or calculated. The field strength has declined over time, but the temporary spikes that you see, the higher energy spikes occur in the non-bipolar, and then the lower energy spikes occur in the bipolar energy. But because the bipolar energy represents such a large percentage of the net energy, the net effect is still downhill always. It's never long-term raised up and held at a high level and then slowly back down. It's just always continually downhill.
Okay, so I'm not sure what that so with these events, these excursions do change the magnetic strength of that polarity. So these excursions are not a reversal of the polarity of the inner core. They're only a reversal of the polarity of the outer core. So they do change the magnetic strength of that field, but they are not a reversal. And you still haven't shown where you got these dates from that you're saying are so consistent that they have to have happened, once during the 7-day week and once during this time. You don't have anything to back up those actual numbers. Now, I do want to mention that the Nobel Prize winner, Patrick Blackett, who, I can grab you their paper, they tried to find a correlation, and that's a Nobel Prize winner. So if you think you know more than a Nobel Prize winner, sure, go at it, TRock. He did a series of experiments looking for a fundamental relationship between angular momentum and magnetic moment and found absolutely none. So you are 100% wrong on that. You are 100% wrong, and a Nobel Prize winner agrees with me.
Say that again.
Nobel Prize winner Patrick Blackett, who is the father of dynamo theory, currently the theory that you're trying to overturn, did a series of experiments looking for a fundamental relation between angular momentum and magnetic moment, but found none.
I'm not making a correlation between angular momentum. You have to have a.
You did.
So this kind of goes back on your idea of where did the magnetism come from, and I said it came from the core. what you're talking about does not discredit.
But how did it produce the magnetic field? You can't just say it came from the core like it's some kind of swamp creature. How does it generate the magnetic field?
So I think you would agree that in good science, you can basically make predictions based on your hypotheses, correct?
Possibly, yeah. It depends what they are. I think a good hypothesis would exclude, you'd have to have robust evidence. You would have to have reliable hypothesis, like something that is only indicative of the one thing that you've proposed. Because if I make a hypothesis like I will get a pizza and then I order a pizza, that's not very scientific, is it? You have to have something that shows that the only way to explain it is your hypothesis. So it has to be unique.
So it has to be unique. Okay. So my real point, it was meant to be simple. Good science.
But this doesn't answer.
I'm getting
how it works, how the iron core
I'm
produces a magnetic field, which you don't seem to want to answer.
I'm getting there. I'm establishing the fact that good science makes predictions, makes testable predictions, right? So we've talked about this extensively in the past. Dr. Russell Humphreys basically surmised that the origin of the magnetic field in the earth, per the biblical account of its history, is that the earth was formed from a body of water. And so what Humphreys surmised was that the initial body of water was pure. It was basically pure water with all of the molecules aligned in one specific direction, which gives a net zero magnetism. Because water, as it turns out, water actually has a very weak magnetic field. And so what Humphreys imagined was that it was net zero because all of the molecules were perfectly aligned, and then in an instant they were de-aligned, which induced the magnetism into the body that is now the Earth. And he basically surmised the exact same process for all of the planetary bodies. And so what he did was he said, okay, if that's true, then it's a function, the actual field strength of the Earth's magnetism is based on the volume of the planet. And so he basically wrote the physics formulas, the standard physics formulas for it, and then said, okay, let's go take a look at Uranus, for example. We know the volume, we know the size, we know the volume of Uranus, or Uranus, as most people call it. We know what its volume is. Therefore, we can use this same set of field equations and calculate what the field strength of Uranus was at creation week. Then you can take this same half-life concept and calculate forward what it should be today. When Humphreys did that, he actually put a number on paper what the magnetic field strength of Uranus should be. Well, guess what? So did the secular scientists in their own view of a 4.5 billion year Earth and roughly 6 billion year solar system, whatever the number is for Uranus. They did the same thing. Obviously, it's quite obvious that they would come up with two completely different numbers. Well, Humphreys did this before they did a satellite flyby of Uranus. And when they actually did the flyby of Uranus and measured the field strength, guess what? Humphreys was almost spot on. He was off by an order of about 3. And I mean, literally just a factor of 3, whereas the secular scientific paradigm was off by several orders of magnitude. So where did the Earth's magnetic field come from? Humphreys described it very well. It came from water.
So now you're sort of saying that the magnetic field is generated by water created magically at the creation week. For some reason, where is this water? Why don't we drill down and find? This is the most ludicrous thing I have heard. All of this is simply based upon your belief in the Bible and these people's beliefs in the Bible. There is absolutely zero credible evidence for this, and just that some guy made some predictions that weren't actually that accurate, but suddenly you want to say, hey, that's proof. Water is not does not produce a magnetic field. I'm sorry, TRock. That is not what is happening.
I'm sorry, you
the
don't
whole
follow standard
idea
physics. It does.
that well, not big enough to account for the magnetic field of Earth. I mean, come on, TRock. And all of this goes against dynamo theory, which is the accepted scientific literature. If your guy Humphreys wants to demonstrate that the biblical account is true and that water, of all things, magicked up somehow so it's got zero net polarity, and you even said he imagined. Yeah, I believe he did imagine this.
I think I said he
if he wants to go and prove that, then he should produce a scientific paper on it, show his research, and then present that. But what we don't do is introduce into science things you believe because of a book that you like, written thousands of years ago by some ancient peoples. That's what we don't accept. Because if you follow that logic, we have to let in all kinds of things like the Bhagavad Gita and, Shiva creating things and all kinds of nonsense that just does not belong in science. I'm sorry, TRock, but your personal beliefs has nothing to do with the Earth's magnetic field. And the whole idea that you can sit here and claim that, hey, it was water that did it and sustains it somehow, we don't know how, prove it. Demonstrate that.
Pay close attention. I never said water sustains the magnetic field. You've imagined scenarios. You've imagined circumstances. You've imagined words that I've not said. None of that. You've said a whole bunch of stuff that I have not said, nor do I think is true. Humphreys not only did it for Uranus, he did it for 3 or 4 extraterrestrial, inside our solar system, planetary bodies, including the sun. And also surmised that, and I use the word surmised, not imagined, but he has actually written scientific papers on this. They're out there available to read. These are not based on, just bizarre, how you basically conflating this extremely well written scientific endeavor using standard physics formulas with basically somebody's random religious beliefs. They're 2 different things. He used standard physics. And again, not just Uranus. He used the same method on the Earth, Saturn, I believe Jupiter as well, and the sun. It's not random. It's not religious hullabaloo. It's standard physics, calculating. And what I said was the original field was induced by water. It can sustain itself by reason of the fact that it's an iron core. It doesn't need water to maintain its magnetic field anymore. It had to start somewhere.
Yeah, and the problem with Humphreys' sort of measurements is that his dipole creation is entirely a free parameter. The Humphreys table shows that. Excuse me, I'm talking. Excuse me, TRock. I'm very polite to you. I'm talking right now. It shows that the dipole for Jupiter is 1.6 times 10 to the 27, Saturn 4.3 times 10 to the 25, and for Earth. From those values alone, there's no reference to any theory. You can see that the dipole values for Uranus and Neptune must be larger than Earth's and smaller than Saturn's. So anything in the 10 to the 23 to 10 to the 24 range can just be an obvious guess. And you'll say, hey, it's close enough that he is correct. All Humphreys has to do is come up with the dipole of creation about the same as Saturn's now. And the result, because the size of the planetary bodies, it's going to be very nearly right. So we do know the dipole values, which is Uranus 3.7 times 10 to the 24 and Neptune 2.1 times 10 to the 24, to agree with Humphreys' order of magnitude. But to hail this as a confirmation of the theory isn't very accurate. He's basically made an educated guess and said, hey, it's close enough. And then the creationist people have said, hey, he's made a testable prediction. No, he hasn't. The fact that his theory depends on the magical creation of water, because this water was created by a god, correct?
Are you done?
I am, yeah. That's why I asked you a question.
You've completely conflated the fact that secular science tried to make a similar prediction. This was pre flyby of Uranus back in the 90s, pre flyby. Everybody got to make their calculations before they made the trip. That means that it's not a guess when you get 4 planets in a row correctly, and the opposing paradigm is off by 6 or 8 orders of magnitude. That's not a guess anymore. That's a prediction based on a specific amount of passage of time. And so it was highly accurate.
It wasn't highly accurate. It wasn't. It was within 10 to the 23 to 10 to the 24. You could guess anywhere in there, and his wasn't that accurate. It just wasn't. I'm really sorry. Humphreys also did not believe that the Earth's magnetic field reversed. He absolutely fought against that for a long time until he finally accepted it. So you've got to explain why this champion of science apparently cannot admit the magnetic reversal of the Earth's polarity until the evidence is overwhelming.
I'm not sure where you're getting those ideas. I'm not sure what Humphrey's stance was back in the 90s. All I'm saying is that he correctly predicted magnetic fields of multiple planetary bodies and was correct, and not off by the numbers that you've cited. It's the secular paradigm that was off by such huge orders of magnitude. Humphreys was off by a factor of 3. That's it, 3. That's incredibly close under the circumstances, considering that nobody had been out there yet to measure what the field strength was.
Yeah, so that's because he leaves a polarity open so it can be reinterpreted to be close enough to what he deems. And it's not even that close. If his theory was correct, and plus, if you want to say that that is what caused the polarity of the Earth, you've got to demonstrate how this water came to be under there, how the water generated this. You can't just say, look, God just threw this water down there, stop the polarity. You've got to demonstrate that that actually happened, and that's something that you haven't done, and he hasn't done. It's just asserted that to be the case, basically made some vague predictions about planetary bodies, and then said, hey, call it a day. That's my theory proven. No, you've got to actually publish these results, have people who work in physics check it, because you're not a physicist, neither am I, and have them verify that this is actually a correct and very accurate prediction, which, from what I'm seeing on the writings of this physicist, it absolutely is not. The algorithms and the calculations that Humphreys is using is intended to give a vague amount where he can throw up his hand and say, hey, it's good enough. And you have already admitted it was not exact.
It wasn't exact. It was it was 6 to 8 orders of magnitude more exact than the secular version of the same prediction. 6 to 8 orders of magnitude more precise.
It's irrelevant. You've got to have your own calculations for what you're trying to demonstrate. You've got to have your own.
You made the comment over and over that it's just imaginary physics or something to that effect about the whole idea of water and how it induces a magnetic field. Water is known to have a very weak magnetic field. That's not hidden science. That's not somebody's secret in the world of physics. It's a known, understood characteristic of water. It has a magnetic field. It's extremely weak. And so with theoretic calculations, yes, because we have no de-aligned, or we have no perfectly aligned water molecules left in the world. So with some theoretical physics, what you can show on paper is that if the water molecules are perfectly aligned, the magnetic field strength becomes 0. I don't think anybody in the secular science community will deny that. Anybody. And so what Humphreys is saying is, if you hypothetically start with perfectly aligned water molecules and then suddenly scramble them, you will induce a magnetic field. and it's understood water has a weak magnetic field. And so if it's going to induce it, there are obviously a range of possibilities depending on what are you inducing the field into. And so the theory, of course, is that it's inducing it into an iron core. There is nothing unscientific or non-standard physics about that. Nothing.
Yes, but there is about the magnetic field reversing itself and becoming stronger when it reverses. There is something really unscientific about that. And there's something really unscientific asserting that God put that water there and generated it, because it's not there now, and generated it so it would transfer this charge. It completely disagrees with science. The dynamo theory is the currently accepted model because it matches up with everything we see. It matches up with everything, while this Humphreys thing, it hasn't even been accepted by peer review. And why hasn't it been accepted by peer review? It's basically not accepted because Humphreys' theory predicts at once every possible observed field. He can just change that number to fit whatever comes out. So it's useless for predicting anything. He can basically just change that variable, say, hey, it's close enough, that's my theory, and then say, well, I was correct. And this is from a physicist. So you need to run this by physicists because they do not agree. 100% do not agree. And you can always find maybe the fringe physicist who's working at creation research. And as I've said previously, a lot of these people do work for those organizations where Bible comes first. And I want to ask you, if we find evidence, strong evidence, will you believe that or will you believe the Bible?
I believe both. They're not incompatible.
Which one would take priority? Which one would take priority?
Both.
How can both take priority? If you find a conflict between evidence and the Bible, which one takes priority?
So one of the mistakes you're making here is there's a basic mistake in scientific philosophy. When you find evidence, you're finding physical characteristics of what you have in your hand today. What you're not finding is an interpretation. So it's not the evidence that contradicts the Bible, it's the interpretation that contradicts it. We're not debating what evidence exists, unless you want to define evidence in your own specific way to suit your own needs. We're not debating what evidence is. That was my whole point earlier in delineating the difference between what can be measured and what's inferred or calculated.
Well, maybe I should be more specific. Scientific evidence. If you find overwhelming scientific evidence and it contradicts with the Bible, which one takes priority? Because you can't prioritize both of them, because then you're basically...
I take, to be perfectly clear, I take the eyewitness account over everything. I take the eyewitness account over everything. And so I would extend... And this is the thing about the creationist position. We extend this courtesy to secular scientists. If you have a secular scientist that has observed, for example, your idea of this dynamo theory, let's be real clear about that real quick. There is no dynamo theory. That word theory, as many secular origin proponents have pointed out, that word theory has a very specific meaning in science. There is no dynamo theory. There's a hypothesis about a dynamo mechanism that's affected the Earth and its magnetic field over the past alleged 4.5 billion years, but it is just a hypothesis. It cannot be demonstrated in any way.
Well, I put a link to Blackett's paper in there. He's a Nobel Prize winner for the Earth's magnetism. So, I don't know why they gave him a Nobel Prize. Maybe it was because he was just a joker or something. Who knows? So basically you would believe the Bible. And I wouldn't believe for a start, the Bible is an eyewitness testimony. It's writings about claimed eyewitness testimony. There's nobody alive today that can be an eyewitness for it. The whole idea that you would believe a book over sort of scientific reality and then say, oh, well, it's your interpretation. That's what the scientific method is for. It goes through a process. We don't just believe somebody because they say something like, I witnessed a dynamo. No, that's not why we believe people. It's because we do this series of testable predictions aimed at falsifiability, and it goes through a peer review process. We don't just believe that person because they claim to have seen it. That's completely wrong.
You know what I really don't believe? I don't believe people's calculated version of history, because if somebody who says they have seen something is cannot be credible, somebody who has not seen something surely can't be credible either.
I don't understand what you're getting at. We're talking about sort of scientific evidence of the age.
Well, you're
physical
about
evidence.
Philosophy of
eyewitness accounts is not physical evidence. I'm really sorry, TRock, to break it to you, but it's not. It is anecdotal evidence. It's not physical. You cannot physically look at that memory they have of seeing something. All you can do is hear their testimony. So it's not physical evidence. And I would like to, before we run out of time, is talk about ice core samples and how you explain away the 800,000 years we find in ice core samples, and why we have sort of multiple magnetic reversals in those samples as well.
So again, I'm not contesting the idea of magnetic reversals at all. Dr. Steve Austin's actually done quite a bit of work on this very subject of magnetic reversals. Now, as it relates to ice cores, the problem with ice core dating at all is that they literally, and I brought this point up earlier about how averages are actually, or most rates applied to deep time are actually averages. The problem with averages in general is kind of summarized like this. If you have $0 and I have $10, the average amount of money that we as a group have is $5. The problem is neither one of us have $5. One of us has 0 and the other one has 10. The average is completely meaningless in that context. And so
no, not for ice core samples, because ice core samples we can literally. Yeah, sorry, I do apologize.
So the problem with the ice core thing in interpreting every single light and dark layer as an annual event for winter or summer, their freeze thaw cycles supposedly, is that's not how real world proceeds for developing layers in the ice. And we know this, what I alluded to earlier was real world examples where we know multiple layers can form in ice cores in a very short period of time. This was the what they call the Lost Squadron, the fleet of airplanes that was landed, I want to say somewhere up near the North Pole. I don't remember the exact location, but anyway, some 50 years later, they decided to go look for those planes because it was an emergency landing. They had to drill through hundreds of feet of ice to get to these airplanes. And what they ended up doing was melting a port down through the entire depth of the ice. And guess what? You can count the layers going down. They look just like the Greenland and the Antarctic ice core samples. They look just alike. You can't tell the difference. But it was well known that it was only about 50 years worth of time passage, not tens of thousands as you would infer by counting ice layers. It sounds real neat whenever you can, in modern science, you can, let's just give them the benefit of the doubt and say over the last several years, they've actually witnessed these single annual layers form. That's fine, but it ignores the fact that if you have heavy snowfall and you have rapid accumulation like we did with the Lost Squadron, it completely ignores the fact that you can literally put together tens of thousands of these banded layers in a very short period of time. And so that is very easily explained by the post-flood ice age. It's the ice age itself that did it, not annual deposition.
Okay, you've got no evidence for any ice age that happened 6,000 years ago or so, or however you're claiming Noah's flood. What, Noah's flood? 4,000 years ago or something. I'm sorry. So this just shows you do not have any understanding of how ice cores are gathered, how they're sampled, how they're read, no understanding whatsoever. In fact, I showed a picture of an ice core sample with an annual layer of ash to show that, hey, we can tell what happened by year in ice core samples. You've completely ignored that. Your choice. We know that these form year by year because we can see it happen today. So you can't explain why they happen year by year today and create that light and dark banding. But you want to say, hey, that didn't happen in the past, even though it's happening right now for some reason. Who knows? They're not averages. When we count these layers, they're not averages. And they put in a degree of you're talking about for rocks when they do radiometric dating. So you've gone back to that for some reason. I don't know why. But in that they give a error margin, which in order for your error margin to be correct of 10,000 years, it would have to be millions of percentages out. You're talking from 4.5 billion to 10,000. There is no error correction that is going to account for that. And you trying to cast doubt on the process and saying, hey, it can be inaccurate. Yes, we know. It can be an average. Yes, we know. But for that to be millions of percentages error is unbelievable statement to make, which you have nothing to support. Now, it's amazing you went to the Lost Squadron, because that was a fighter that landed on an active glacier, which does have a higher snowfall than other places. And it was sunk because on an active glacier on the coast of Greenland, you will have melting that occurs, allowing those fighters to drop. We don't collect ice core samples from active glaciers, at least not when we're trying to measure the age of the Earth or the ages 800,000 years that's gone by. We don't collect them. We collect them from inactive glaciers. So that Lost Squadron just demonstrates a fundamental misunderstanding of how ice core collection works. You have no understanding, because that Lost Squadron is an absolute shocking argument.
Yeah, no, the whole idea that we don't collect ice cores from active glaciers, a modern scientist in the 21st century has no idea how active Greenland or Antarctica were 3,000 years ago. They have zero idea. All they know is that they assume today that the layers that they count, and so another really fine point that I think you've conflated very well is that your margin of error is a function of how accurate you can count something, not how valid the method is as a dating scheme. It's completely two different things. You can have whatever super tight tolerance you want on a margin of error. Has nothing to do whatsoever with how accurate the dating method is. Ice cores, and so you talked about the ash too, which kind of makes a tie-in between radiometric dating and ice cores, because when you have ash layers, it's volcanic ash, right? Which means you can hypothetically do something like potassium argon dating. The problem, of course, is it's all circular reasoning, because there is no such thing as an accurate what's the word I'm looking for? There's what you would call in science a control group. In order to know anything like potassium argon dating is accurate, for example, you need a control group. There is no volcanic ash of known age that potassium argon dating works on. Not one. Didn't work on Mount St. Helens. Didn't work on Vesuvius. Didn't work on Kilauea. Doesn't work on any volcanoes of known age. And so where's the margin of error in that? Potassium argon dating doesn't work.
Yeah, so potassium argon dating doesn't work with anything younger than 1,000 years. We can date things older than 1,000 years. So that actually 1,000 years. So that's why I might say 1,000 years. Yeah, if you actually looked at my presentation, potassium argon dating is 1,000 to billions of years. But you cannot ignore the fact that the half-life of potassium, or potassium 40 to be specific, is actually 1.2 odd billion years. So how do you explain that, TRock? Because you haven't done anything to cast doubt on the ice core things. You've just demonstrated your fundamental misunderstanding and then gone back to potassium argon, for instance. But the whole point is that we can know how much we know the decay rates of potassium. We can measure that in a laboratory. We know how fast it decays. That is a constant, reliable marker. That is what you would call measured in your strange little types of evidence thing. That is 100% measured. And 1.2 billion years for a half-life, we can tell because there was no argon in the initial sample. There is none. We know that. So under 1,000 years, it does not produce enough argon for us to measure. But we can measure it.
No, if that were true, then whenever they did samples on Mount St. Helens, they wouldn't have come up with ages ranging from about 300,000 to about 2.1 million years old. There was lots of measurable argon that should not have been in the Mount St. Helens samples. It is the control group I was speaking of. So argon, correctly, you pointed out correctly that argon is an inert gas that doesn't diffuse itself into the rock per se. No, but it can still migrate in and out of it. And so in deep geological time, you've had lava basically being magma when it's still in the mantle. You've got this heat being applied for billions of years before it's finally released. And then I don't know what you think you're supposed to get for a cooling scheme, but what one of the basic assumptions of potassium argon dating is that there was no argon present after the initial formation of the rock after it hardens. But Mount St. Helens proved that to be absolutely wrong.
Actually, I said that there's no argon present, in the samples, which are not ash, right? This is what you've got to understand. Like, you're talking about ash. What I'm talking about is mineral structures, such as crystalline structures, that have no outside influence. That argon does not permeate through them. And we know this because we have done it. Geologists have confirmed it. So this whole idea that the argon is coming from somewhere else, in Mount Helens, the argon could have come from the atmosphere, got permeated the ash. Sure, it's a bit weird. And the whole point is that we don't use potassium argon for that reason. Anything under 1,000 years, no. We have to get the samples from crystalline structures. So how do you explain the uranium, the decay rates of uranium and decay fission track matching the age of the Earth exactly with the potassium argon track, matching exactly with thermoluminescence, which isn't even a decay rate. That's measuring the effects of radiation and heat upon crystalline structures in the material. And that matches up exactly with a multitude of other methods used. How do you explain that?
So this idea, and it's more lip service than it is reality, this idea that fission track dating exactly matches this dating exactly. So to put a finer point on it for the audience sake, there are a number of methods out there for radiometric dating that not specific to the parent-daughter system that you're using, but more specific. So there's like what they call the whole rock method. There's the isochron method. There's the I can't remember what the other term is, but you can do individual crystals. There's even a laser method for counting atoms in individual crystals. But as it turns out, you can, from the same crystal, you can get different ages, whether you do this face or that face, whether you do an edge versus a face, that sort of thing. You can get all kinds of different answers. Which one is right? Which one do you think is right? Well, it always goes back to geological context. The reason, one of the main reasons we know that no radiometric dating works for deep time is that there is no such thing as radiometric dating that doesn't first have to pass a geological context. And so they're not picking which one of those methods is the correct one to use until after they say, okay, where did the rock come from? Well, wait a minute. Why do you need to know where the rock came from? If all of these methods cross-confirm themselves for the same sample, you don't need a geological context. But that's not how radiometric dating or geology, either one, proceed. And so I've got in front of me, there's some, creation.com has some references to incongruent radioisotope dates using the same technique, argue against trusting the dating methods that give millions of years. And then there's also, they have a reference to incongruent radioisotope dates using different techniques. So they're incongruent or discordant, as it were, in the scientific literature, both by using the same technique or by using different techniques. It's what you want published and what case you're trying to make. If you're trying to make the case specifically for radiometric dating being accurate, that's really difficult to do given how many discordant dates there are. If you're trying to make the case for a specific sample, then according to what you said, I could take any one sample and use 3-4 different methods and come up with the same dates. But that's not what the literature actually reveals. What the literature actually reveals is you're going to get discordant dates if you mix and match methods.
So all of them fall within a range of error margins. And this is the thing that TRock is conflating for. He's saying, hey, we get these error margins and we get slightly different dates. They can't all be right. We're aware of this. We know that they have error margins that we adhere by. And sort of, I would not use Creation Institute. They haven't managed to get anything published on this subject. They do make claims that have been debunked and falsified by actual geologists and scientists for ages. They're not taken seriously within the scientific community for good reason. They keep publishing these things which keep getting debunked, and they keep taking down the websites. These kind of claims have no scientific merit. And I'm really sorry if you believe that, TRock, but I would go to peer-reviewed geological scientific papers rather than the propaganda produced by Creation Institute. This has been debunked multiple times. The whole idea that you can use, and what you were talking about was optical luminescence, the idea of using lasers to test the flaws within a certain mineral structure so you can tell how old it is. Yes, and it comes up with the same dates as well. The problem with Creation Institute, and especially the RATE project, is that when you get actual scientists testing their work, they find multiple errors in how they collect the samples, how they test the samples, what they do, and how they do it. So when you actually submit Creation Institute to the rigors of science, they fail at every turn. That is why they cannot get things published. In fact, I read a RATE article where it actually brought the Bible as part of their evidence, which is just ludicrous because the Bible has no place in a geological paper submitted to science. This is why they can't get published. And so them claiming that these things are all out of the ordinary is not very good evidence, and certainly not good scientific evidence, because they have not given their papers over to be assessed by actual professionals. They just tell people like you, TRock, and expect you to believe them. Well, I don't. I believe the geophysicists and the actual scientists who have been doing this for years and years and years, rather than Creation Institute, who have a vested interest in showing that the Bible is true.
So what I actually believe, and I'm going to keep this in a scientific context, what I actually believe is physics. And so what you measure and what you calculate being different than the actual physics, I believe in physics processes. And so, and again, I think I pointed this out earlier, that creationists give secular scientists the benefit of the doubt when it comes to what they've actually seen and measured. I'm not really arguing against any of the physical evidence. The debate tonight, of course, is supposed to be on whether or not the physical evidence demands an old Earth interpretation or precludes a young Earth. And nothing in physics, you've not named one physics process that precludes a young Earth, not a single one. The problem with radiometric dating, well, let me point this out real quick. I'm reading from a Creation article that's referencing Nature, which is a secular science journal. Nature, volume 321, pages 766 to 769, obtained 100, and this scientist by the name of W. Comston and R.T. Pigeon obtained 140 zircon crystals from a single rock unit and subjected them to uranium concordia and thorium concordia dating methods. One crystal showed a uranium date of 4.3 billion years, and the authors therefore claimed it to be the oldest rock crystal yet discovered. Serious problem here is that all 140 crystals from the same rock unit gave statistically valid information about the rock unit. No statistician could ever condone a method which selected one value and discarded all the other 139. In fact, the other 139 crystals show such a confusion of information that a statistician could only conclude that no sensible dates could be extracted from the data. So this is in the scientific. This is in the scientific literature, and I gave you the volume and the
okay. So, no. You said it was a Creation Institute article, not scientific literature. Scientific literature. I told you specifically that it's a reference to volume 321, journal articles from a reputable journal.
Oh, you guys are talking about.
Yeah, if TRock could let me talk, please, because you've said something that's very, very out there. This is a claim by Creation Institute. You said it was a Creation Institute article. I heard those words come out of your mouth. Their interpretation of a paper that you're claiming their claim is a scientific journal. No, that's an article by a focus group who was focused upon the biblical narrative. That is what it is. It is not a scientific journal. The original paper may have been a scientific journal, but Creation Institute may not have interpreted correctly. So don't tell me that their article is a scientific paper, because it is not. And the problem also with zircon is that the Creation Institute claims that extrapolating data on the rate of helium diffusion in these zircons can only be explained by a young Earth. This is one of the claims that they made. However, all their data was taken in the laboratory under sort of the vacuum of the laboratory, and actual diffusion rates in the field conditions were known to be considerably lower. This is the kind of thing that they get busted on constantly. By a factor of 1,000 or more, when the diffusion rates were known to be lower. They claim to have meticulously accounted for all crystallographic features. However, the diffusion rate of noble gases and minerals is so complex that it is not considered by geochronologists to be reliable for any dating implications. So this is the kind of thing that they do. They interpret scientific results under a biblical narrative, and it just doesn't fly as scientific literature, TRock. It doesn't.
Okay, so here's what I would challenge you to do. Go read the Nature Volume 321, pages 766 through 769 that I cited, and then come back and tell me that the author of thiscreation.com.
Give me a link. Give me a link. Give me a link.
I don't have a link to the article. It's just a reference to the journal. You can find the Nature journal.
Which volume of Nature was it?
321.
321, and what was the article called?
I don't know, but it was pages 766 to 769.
It's not exactly a citation, TRock.
So his direct citations are in here. If I can find where this is.
So is it the evidence, the Earth's pre-4,000 million age, million annum history, evidence from trace element and microstructural investigation of 4,000 to 4,190 million annum zircons from granitic gneiss northwest of Yilgarn Craton.
So you got the actual data chart by chance?
Yeah. So the ages that they, the zircons that they have formulated ranged from 1.8 million. 1.8 billion to 4.1 billion years.
Mm-hmm.
Is that what you're saying?
So he doesn't tell what the age range here is. What he's saying is one crystal showed a date of 4.3 billion years. But there were 140 crystals sampled.
Right. What ages did they show?
It doesn't. What it says specifically here is that the other 139 crystals show such a confusion of information that a statistician can only conclude that no sensible
Yeah,
dates.
no,
can
I
be
realize
extracted.
Creation Institute says that. I realize Creation Institute
Okay,
says
so
that it
my
tries
question
to
is,
hold on. Let me finish. That it tries to apply statistics to a field that they don't really understand, and say, hey, statistics. The people writing the paper are geochronologists. They may have knowledge of why some of the samples are inaccurate, why they may have been contaminated, why they may have other reasons why they're not considered. That for you to just go to a Creation Institute sort of saying, oh, well, if it's a statistician looked at this, they would. It's not a statistician doing these experiments and these analysis, TRock. You've got to understand that, right?
I think what I understand is that you're not looking at the actual ages given. You're blindly believing what the authors are claiming
I would
to
like
be
to,
a
but I don't
4.3
have a citation.
4.3 billion year old rock based on one crystal. So could they have reasons? Sure, they could. What are the reasons given in the paper?
I don't know, because I can't find the paper. I've put in Nature 321, page 766, 769. I've got a Geochron article by Dr. Nelson Robinson Myers. I'm not sure if that's the right one. If you could just cite it for me, like give a citation, that would be great. But you don't seem to be able to cite this paper. I might add, this paper that you are relying, like TRock, a citation is authors, name, institution, journal, pages, and preferably a digital object identifier, which identifies the peer review and the actual identifying number that shows that the paper has been through that scientific process. That is a citation, not or even a link, not just Nature. This, you don't even have the name. How could you possibly be citing it?
Volume 321 is a legitimate citation. It's called a scientific journal for a reason. That's the volume number.
Volume 321 covers the 26th of June 86 to the 1st of May 86. I mean, it covers it covers like 2 months. It covers like an eighth of a year.
And so the author of the author of the paper is given as W. Compton and R.T. Pigeon.
R.T. Pigeon.
And gentlemen, as you do this, let me just let you know that we are just about to hit the 60-minute mark on this very engaging discussion. I got to say, you gentlemen both know how to make a very entertaining and engaging discussion period. So if you guys wanted to wrap up this specific topic, and then maybe we will move into our closing statements.
So I want to backtrack just a little bit on ice core dating then, just real quick as we're winding down here. I was accused several times of not understanding the method because I used the word average. I understand very well what ice core dating is. It's literally counting the banding. That's all it is. And every single light dark band is considered to be 1 year. And so you literally have to count, if you are supposing 20,000 years of the passage of time, you have to literally count 20,000 light and dark band sets in an ice core. And so there's no mystery. What happens is when you get below a certain depth, they become so blurry they're virtually indistinguishable one layer from the next. So from there, what typically happens in very quote unquote ancient or deep ice core bands is you quit counting and you just throw some average thickness per band at it and just do the basic math and say, oh, this is how many years it must be, because they're too blurry to read between. You can't count them visibly anymore, not even under a microscope. They fuzz together so much. It's the plasticity of ice under high amounts of pressure.
Yeah, so that's not the only thing that they use, and they do use other techniques when it gets down further. If you'd actually listen to my presentation, they also do use reversal of the Earth's magnetic field, which they can tell from bits of ferrous metals trapped in the ice. They also use sort of like the ash band that I showed you. They can tell when a year was, so they can match it up with other years. They also use something that we didn't get to talk about, and I'd love to talk about is Milankovitch cycles. Milankovitch cycles, which is basically the temperature changes, because we can tell the temperature in these ice bubbles in the ice cores, and they match up perfectly with the Milankovitch cycles, which these cycles between the precession of the Earth, the eccentricity of the planet, the precession of the orbit, these all match up with these wobbles that the Earth does on its precession, and those are sort of, anywhere from 21,000 years onwards. So it's very strange that you sort of say, well, the only thing they do is count the bands. Where they do have, say, some mineral deposits in the ice, they do use radiometric dating as well. So it's weird that you'll say, oh, the only thing they use is counting the bands, when I clearly pointed out in my opening presentation that is not the only thing that they do.
That's not what I meant when I said the only thing they do. What I meant was the simplicity of ice core dating itself. I am well aware that some other oxygen isotope ratios and things like that are used with ice core samples. I know that. I wasn't saying they don't do any other thing besides counting ice layers.
Well, I mean, simplicity doesn't necessarily mean inaccurate. That's the thing. A tape measure is simple. It still can be accurate. But really, what layer does it go back to before it's compressed and you can't read it? Because it certainly isn't 10,000 years. It's way beyond that. I believe about 130,000 years. Oh, then you are 100% wrong. I'm really sorry, TRock, but that is not the layer where it's compressed enough that you can't read it.
I'm agreeing with you. It's not 10,000 years. It's deeper than that. I get it. That's not the point.
Deeper, yeah.
So in keeping with the question that's the center of the debate, one of the things you have to show is that there are no physical processes that can account for those same ice cores within a 6,000 year time frame. So what you're implying is there is no way that enough ice could accumulate in a 6,000 year history to produce the exact same ice cores that you suppose are hundreds of thousands of years old. Tell me which law of physics was violated in order to assume a 6,000 year history in those ice cores.
Eccentricities in the orbit of the Earth, Milankovitch cycles. There is no explanation for young Earth going up 6,000 years to explain the changes in temperature, while the Milankovitch cycles line up perfectly. The changes of the Earth's orbit lines up perfectly with those. If we assume, or if we know that those ice core samples are in fact going out to 800,000 years for the 3 kilometer sample, for instance, it also matches up with our radiometric dating. It also matches up with the layers that we can see. And what we see now, there is nothing presented from you that says these layers form more than annually from the summer melting the snow and the winter refreezing. There's nothing you've got. And we can see the temperature variation in that as well. So it is cold, hard scientific evidence that is showing us the age of these ice cores, not just, hey, some unknown mechanism from my creation beliefs is somehow making these layers form faster, even though we don't know what it is.
So a couple of quick points. Number one, the Milankovitch cycles have never been observed. They're inferred. The Milankovitch cycles, you can actually do energy calculations on the relationship between the sun and the Earth. Milankovitch idea of the eccentricity of the orbit. There's not enough energy to account for an ice age in a Milankovitch cycle. It's just not there. Those cycles will not trigger an ice age is the point.
I never mentioned ice ages.
Point number two.
I never mentioned ice ages.
The how do you get all these? Well, never mind. Point number two is what you're talking about, the temperature differences. I think, correct me if I'm wrong, but I think what you're actually referring to is oxygen isotope ratios that are inferred as temperature differences, which is in and of itself probably not illegitimate. It's just that you can get variations in oxygen isotope ratios by simply changing temperature and humidity of the atmosphere. It will literally cause differences in oxygen isotope ratios. So you've not demonstrated that a young Earth interpretation, and you pretty much acknowledged that you called the Lost Squadron sitting on an active glacier. Well, you've pretty much acknowledged that active glaciers can produce lots and lots of snowfall. So you've not demonstrated how the young Earth interpretation is denying standard physics. What you pointed out is how the young Earth interpretation denies the old Earth interpretation, but not a contradiction to standard physics.
No, because we don't collect the core samples that I'm talking about from active glaciers. So we only collect them from glaciers that are stable and have been there for ages.
Stable
We can tell because you're talking about an ice core sample, 3 kilometers. That's like 1.86 miles long. Do you have any idea of the scope of that? How many layers have to be laid down for that to occur?
Yeah.
As it turns out, 800,000. But
Yeah.
there is nothing you have said which actually addresses the problem that we can tell. Like you've sort of said, yes, we can tell temperatures by there. I didn't mention ice ages. There's more than Milankovitch cycles that go into when ice ages occur. There is a lot of different factors in that. So it's got nothing, well, I won't say nothing to do with Milankovitch cycles, but it isn't reliant on them. And sort of saying, oh, an ice age didn't happen when this cycle happened. No, that's not how ice ages work. There's more variables that go into when an ice age occurs than just Milankovitch cycles. So you're sort of making a direct comparison there when it's not. I found the paper that you're talking about, and I'll link it straight into the private chat so you can have a look at it. It's basically saying that they found formations between 4.5 million years and 4.0 million years. I've tried to skim through it. I'll certainly read it, this paper, but I don't see where they're having such a large error margin that you're talking about. I don't see it. So maybe you could point that out, because they've even sampled all of it and put all of it in here and said, yeah, there's an error rating of plus or minus 6 million years. Yes, which sounds huge. It sounds huge, right? But when you're talking about sort of 4.5 billion, it's not actually a large error margin. It's only a small percentage error margin, like 15% or so. So even if there is a 15% error margin, fine, great. It's still older than what you're saying it is. And we're aware of these error margins. So I would love to know in this paper where it is, because I don't see it.
I'm not arguing error margins. I've said this multiple times now. A margin of error is a function of how accurate you can count something, not how valid the method is for dating. But I want to keep the focus on, must the evidence be construed in such a way that it completely excludes the possibility of a young Earth? And so what I'm saying is, I'm first going to posit the mechanism for the ice core samples that you believe are 800,000 years old. Yeah, they're not, because the question is, can you get that depth? What did you say, 3-point-something miles? The question is,
usually about 3 kilometers, 1.86 miles deep. Yeah.
1.86 miles, good enough. The question is, can you get 1.86 miles of ice core in 6,000 years? Yes or no, under standard physics? The answer is yes. It's not difficult. As a matter of fact, I'd be willing to bet the majority of that happened in about a 500 to 700 year time frame. Now, why 500 to 700 years? That's kind of a separate discussion, but all it really needs for that to happen is you need an increased level of humidity in the air, which would come from an elevated ocean water temperature. With increase in ocean water temperature of just a couple degrees C, the total amount of evaporation starts going through the roof. And so you can get huge volumes of snow winter after winter for hundreds of years straight and easily accumulate 1.86 miles worth of snow in the biblical time frame. It's not a defiance of physics in any way. It's simply a defiance of the interpretation of a Milankovitch cycle and some of the other methods that you've alluded to that you believe have to be interpreted in an old age, in an old Earth context, but they don't. Oxygen isotope ratios can be altered drastically through change in temperatures and pressure. The ash layers that you're talking about, you can get any date you want to practically from pulling volcanic ash samples. I've already talked about that. That's not a contradiction of physics. You can make the data, quote unquote, the data say whatever you want. The ages that are assigned are not direct measurements. They're interpretations of measurements. As a matter of fact, at 800,000, I think the number you threw out there, 130,000, is roughly the boundary of where you can actually physically count the ice layers.
So from memory, yeah.
Okay, so I'll accept 130,000 sets of banded layers as the maximum depth you could count to. Everything beyond that, you have to use a different method, right?
Mm-hmm. And I pointed those out.
Okay.
Yeah, so yes, and humidity in the air would be great, except that we have the bubbles trapped in the ice, and we know that didn't happen. See, this is the thing you forget. We have that data because the ice traps bubbles. Then we can test to see what actually happened. Well, we've got the air bubbles that show us the atmospheric particles that were there.
Can you clarify? Can you clarify a fine point on that real quick?
So where is your evidence for a rise in humidity? Because we have the air bubbles trapped and it does not seem to suggest that happened. So you don't have the evidence. You're just claiming, hey, this could have happened with no evidence to actually back it up. You're just claiming. Yeah, no, you're just claiming this without any evidence to back it up. It's just these banding is what we see. This banding is what we have. These days, the whole idea that you could get 10,000 years of compacted, because you've got to understand that it's not just 1.8 miles of ice like that's been laid fresh down. It is compacted ice. It's been pressed down really hard. So the whole idea that you could get 10,000 years in 1.86 miles of compacted ice, I'm really sorry, but that defies all physics. There is no measure of snowfall and refreezing that is occurring that is going to cause that to happen. Also, you're defying physics by basically, I don't know whether you accept that uranium-238 has a half-life of sort of 4.5 billion years. But that, for you to say, hey, that radiometric dating is all, we can't rely on this, it is violating what we know physics to be. So I'm really sorry, but, I guess I want to ask you, do you think the half-life of uranium-238 is what I've said it is?
That's interesting that you should ask such a thing, because it's another point that I've never once contested. I readily accept that half-lives of virtually all of the standard radiogenic isotopes are what the mainstream science says they are. That's not a point of contention.
So where did the lead come from if it decays from uranium?
That's a great question. Where does, and this is my original problem I've always had with radiometric dating in general. And it's really exasperated by Dalrymple's idea of going and getting meteorites and lunar rocks to try and use them as a proximity to the age of the Earth. The problem is I said this already, neither Dalrymple nor you nor anybody else in the secular scientific community has any idea whatsoever where primordial uranium came from or primordial radiogenic lead.
That's
either
not
one.
Answering my question. That's not answering my question, because we know that lead decays from uranium. So if uranium has a half-life,
is that the only
why is
source,
there so much lead?
Is that the only possible source for the existence of lead?
Well, if there's another source, then you've got to show that there is another source of lead. I mean, go for it. Enlighten us all.
Mark, a little bit of just focus some common sense on the origin of uranium will tell you that there pretty much has to be a secondary, there has to be a different source besides radioactive decay for lead. There has to be, because otherwise you don't have, in other words, the very process that secular scientists think created the first uranium in the universe almost certainly created lead at the same time.
Well, I mean, the uranium probably, I mean, I'm not a physicist, but I believe it came from cosmic events like supernova and stuff like that.
That would be.
So a question is, do you think the universe is 10,000 years old? What's the age of the universe?
I believe the universe itself is younger than the Earth, and it's approximately
Younger than the Earth.
by a few days, 4 days, I guess.
Okay, so considering it's like light years to the center of the galaxy, the Milky Way, like the Andromeda, you know, it's basically at least 100,000 light years or 100 million light years. I can't remember which, but how did the light get to us?
Well, my personal idea is, and this is something you can't actually prove in the scientific literature one way or the other, but my personal idea is that it gets here instantaneously.
How? I mean, the speed of light is the top speed that anything can travel in the universe. Einstein proved that.
To be perfectly clear, the speed of light, as we understand it, is the two-way speed of light. The one-way speed of light cannot be measured, and every physicist worth his weight in salt knows this. You cannot measure the one-way speed of light. And so how did the light get from there to here in one direction? I'm saying it's probably instantaneous, which means the two-way speed of light, the idea you're talking about, in other words, what's the number I'm looking for? I apologize. I can't even remember what the number is for the speed of light. But
300,000.
Yeah, 3.0 times 10 to the 8 kilometers per second. That speed can still be the average speed of light in two directions, even though the speed of light in one direction is instantaneous. There's no way to know that.
So that defies all physics, because
we
don't get
you need
light
to consult an actual physicist who understands Einsteinian physics.
I was talking instantaneously from a light source like another star. We don't see it instantaneously appear. That is 100% wrong and completely violation of Einstein laws of physics. Nothing can travel faster than the speed of light. Just because we can't measure a one-way speed of light, because when we send that light off, we can't measure it coming back because that's two-way. Just because we can't measure it doesn't mean that it can violate one of the inviolatable laws of the universe, which is the fastest anything can travel is the speed of light.
I'm sorry, you need to familiarize yourself with Einsteinian physics of relativity, because Einstein himself, it's called relativity. Specifically for that reason, you can't know what the one-way speed of light is. You set it as whatever you want it to be.
That doesn't mean it's faster. Like, just because we can't measure it doesn't mean that it's faster than the speed of light 300,000 kilometers per second.
So I don't really want to spend a lot of time.
What it means is you are just assuming it because it backs up your personal faith, and that's all what we've got all debate.
Einstein literally said you can assume whatever you want. He literally said that about the one-way speed of light. You can assume it to be whatever you want.
He also said that nothing can violate the speed of it. Is the fastest thing in the universe. It is the limit on speed in the universe. Well, if you could find a citation where he said, okay, so I'll find something that says Einstein says that the fastest thing possible in the universe is the speed of light, the fastest speed possible. Would you like me to do that?
Help yourself. I don't really want to get bogged down on the speed of light, because what I wanted to do is keep the conversation centered around is physics violated by a young Earth interpretation? Because that has to be true in order for you to assume that, per the topic of the discussion, does the physical evidence demand an ancient Earth? It has to. Young Earth has to be a violation of physics in order for that to be true. and it's not.
It is.
You've still not shown where I've violated any physics. What you've
Sure I have.
suggested is I've violated interpretations of events.
No. You've violated physics by basically asserting that radioactive decay can't be measured correctly. You've asserted that.
I didn't say that.
Let me say, all of these are assertions. So when we're looking at it, I don't have to basically go through and say, oh, well, I have to find a law in physics which you have violated by doing this. All I have to show is that the physical evidence points to an ancient Earth. That's what I've got to do. And that is what I have done. All you have done is basically say, no, that's one interpretation of the evidence. Okay, it's the interpretation by the scientific community, which is the most reliable and robust process we have for determining evidence, versus what I think, because my book must be true. And that's where we're at the moment. I'm basically saying, hey, all of this scientific data, all of the evidence we've collected, all points to this one thing. It all correlates. It is all pointing at this one age, or, around this one age, because it's not 100% accurate. And I realize that. You're basically saying, hey, in order to convince me otherwise, well, I can't convince you otherwise. Because even when I do point out how this is a law of physics broken, you say, no, it's an interpretation that the laws of physics have been broken.
Mark, I've conceded the idea that decay rates as we measure them today are constant, and many of the radiogenic isotopes are on the order of half-lives of hundreds of millions and billions of years. I've conceded all of that. That's not, so I'm not quite obviously not defying physics per se. Besides that, I think it's useful to understand that just like the relationship between Milankovitch cycles, ice core layers, and oxygen isotope methods, and other radiometric dating methods, how they're basically calibrated against each other, which is just a sleight of hand circular reasoning is all it is. You can calibrate one against the other, and then calibrate the other one against the first one, and you just do that, and then they all agree, and then you walk away going, see, the scientific literature shows that all these methods agree. Well, of course they agree. They're forced to agree. That's where the calibration methods come from. There's no such thing as an accurate calibration that's done external to human observation. You can follow that through carbon dating. So when we talk about, does the physical evidence demand an ancient Earth? Carbon dating is another really good one that tells us that the physical evidence does not demand an ancient Earth. We've got carbon-14 in everything, everywhere. Everything that's biological in nature, including things that aren't biological in nature, like diamonds. So am I violating physics in suggesting that 6,000 years can account for measurable amounts of carbon-14 in diamonds? No, I'm not violating physics. Am I violating physics in saying that, okay, some radiogenic leads have, on the order of billions of years half-life? No, what I'm suggesting
why
is...
do you have to violate physics to be wrong? Have I violated physics anywhere?
Because that's the only way that actually you do have to violate physics.
No. Have I violated physics anywhere?
Not directly.
Then I'm right as well. How can we both be right? If it takes violating physics to be wrong, how are we both right?
My comment is that you haven't done it directly, you've done it indirectly. So
I think that's just a cop-out. That's 100% cop-out.
That's exactly why I pointed out
thing.
You don't know where primordial uranium came from. You have to violate physics to get it. In the Big Bang paradigm, you literally have to violate physics to come up with uranium at all. Yeah, you do.
That is not a belief shared by any particle physicist, any cosmologist, anybody with any sense of learning. Supernova create the heavy elements when they explode.
Is that a known fact, or is that just a hypothesis?
Well, I mean, if you want to just be a science denier, sure, go for it. You basically denied science all throughout this and pointed to papers by a creation research institute as your scientific literature. So if you want to take that as given, I mean, great. But you've sort of said, hey, you haven't accounted for where uranium came from. I said, hey, I have. And you've said, do you know that for a fact? You have made no end of assertions. You have absolutely no evidence for whatsoever. You have just said, hey, it was water that created the magnetic field. No evidence for that. Nothing to back it up. Only your religious belief to back it up. Yet that's a claim that you made. The person that's been making unwarranted assertions through all of this has been you.
So I made the claim a little while ago, and I'll still stand by it. What was I saying about the the dynamo theory? I said it's not a theory at all. There is no theory in the open literature about the dynamo. It's a hypothesis, not a theory. The same is true for primordial uranium coming from supernovas. There is no theory in the open literature about it. It's a hypothesis, an unproven hypothesis, an unprovable hypothesis. As a matter of fact, there's no way to come up with formation of a rocky planet in standard physics using Big Bang cosmology. There's no way to come up with the formation of a star. There's no way to come up with the formation of a rocky planet. There's no way to come up with the formation of primordial uranium. There are no theories in the open literature about how that works. There are strictly hypotheses mentioned here and there by various scientists who think that's where it comes from. They're all origin specialists typically. Of course, you get some crossover between some theoretical physicists that aren't specifically origins leaning. Nevertheless, the point is there are no theories in the literature about where uranium comes from. There are only hypotheses, and they don't make sense in the light of standard physics, because when something explodes in space, it does nothing but continue to get further apart. It does not come together at all. So these rocks that Dalrymple has analyzed, they didn't come from an extrasolar origin, period.
No, you're 100% wrong. Blackett himself won a Nobel Prize for his dynamo theory. So you are 100% wrong. And there are theories which explain cosmology and the accretion disks which led to the formation of these planets. You are 100% wrong and are ignorantly saying, hey, they're just hypotheses. There's nothing to back them up. No, they're theories. That doesn't mean the theory can't be overturned, but they are scientific theories. And for you to sit there and sort of go, no, the research that these people did, the peer review that they went through. If you think they're wrong, TRock, produce your own paper, get it peer reviewed, and overturn the theories. That's what you should do. Unfortunately, you are just talking about things that you do not know anything about, quoting people from organizations that have been rejected time and time again because of their research methods and the way they conduct their research. If you can't do that, don't sit here and sort of say that the work that these people have done isn't theory just because you don't believe it. It's really, really disrespectful to them. It's disrespectful to a Nobel Prize winner. You're basically saying this Nobel Prize winner has no idea what they're talking about, but I do. No, sorry, TRock. No. I'm going to believe the Nobel Prize winner over you, mate. I'm really sorry. And I just want to point out, I'm reading from physics.org at the moment. According to Einstein's theory of special relativity, published in 1905, so it wasn't general relativity, it's special relativity, nothing can exceed the speed of light. The speed is a fundamental constant of nature. It appears the same to all observers anywhere in space. There is nothing that can exceed the speed of light, according to Einstein. So you're 100% wrong.
That's you completely misunderstood what I said. And Einstein himself, it's well understood by people who actually understand relativity. I'm not talking about exceeding the speed of light. I'm talking about the difference between measuring the one-way speed of light and the two-way speed of light, and the difference between instantaneous versus an actual travel speed. They're two completely different things. So
now you're claiming that light can travel instantaneously, which goes against all of the physics we understand.
So how does the Big Bang account for inflation then?
What do you mean? The universe is inflating. We understand this from redshift.
You don't understand the basic Big Bang paradigm. A singularity expands rapidly at many orders. many orders of magnitude faster than the speed of light?
No, that's not what
the
it
Big
does.
Bang paradigm.
No, it doesn't. It expands at the speed of light.
No,
the reason why
it doesn't. That is insane.
the reason why if you just let me talk for a second, the reason why it seems to us that it's expanding faster at the speed of light is because if the edge is moving at the speed of light, but all the space in between is expanding, right? So all the space is expanding, then it appears like to us that it's moving faster, because not only do you get the distance from, say, if there was a center, the center to the edge is expanding. It's also that the space in between us on this side is expanding as well. So space is expanding at the speed of light, but it's expanding at all locations at the same time, which is why it looks like to us it's expanding faster. It's not. It's going at the speed of light, not faster than it.
Sorry, Mark, you're just not familiar with your own paradigm on cosmic origins. I'm reading here. It says in physical cosmology, cosmic inflation, cosmological inflation, or just inflation is a theory. It's not a theory. It's a hypothesis. This is a theory of exponential expansion of space in the early universe. The inflationary epoch lasted from. The inflationary epoch lasted from 10 to the minus 36 seconds after the conjectured Big Bang singularity to sometime between 10 to the minus 33rd and 10 to the minus 32nd seconds after singularity, after the singularity. The reason it's called inflation is because it's literally an inflation of the speed of light.
So when it says exponential, right? So if you've got 2 points in space, okay, and there's an exponential expansion of a meter, it means all of the space in between you expands a meter. That's why it's exponential, which means you don't know what you're talking about. It's because those 2 points is expanding a meter in between 2 points. Just say there's another point a meter away. That has not only expanded the meter in between you and the first point, it's expanded another meter in between the second and the third points. So in fact, from you to that second point has expanded 2 meters, not 1. That is what we mean by an exponential expansion. It doesn't mean that the expansion of that point is faster than the speed of light. You are wrong.
That's where you get into what's known as the horizon problem. It's the horizon problem specifically because that idea of the speed of light being the only speed that the universe has ever underwent, it's bogus because opposite sides of the universe would have to be in thermal contact with each other, but they're too far apart for the alleged age of the universe to have put them ever in thermal contact with each other. It's called the horizon problem, and you're just completely off the mark on your idea of how there was no inflation above the speed of light. It's called inflation because it was above the speed of light.
No, it's not called
inflation. And you're talking about this idea of what we've
light. It's because it's inflation because all points of space are inflating at the same time. Much like if you blow up a balloon, all points inside that balloon are getting further away from one another. That's inflation. It doesn't mean that the balloon is expanding faster than what it is. You have failed to understand a basic concept here that if you have, I could show it with paper, if you have 2 dots and you increase everywhere by a centimeter, that's a centimeter that grows between the 2 dots. However, if there's a 3rd dot and you increase everywhere by a centimeter, it's 1 centimeter to the 2nd dot and then 1 centimeter to the 3rd dot. So that means, relativistically speaking, that distance between you and the 3rd dot is 2 centimeters. But it doesn't mean the dot has moved. It doesn't mean that has moved more than a centimeter. It just means all points are inflating at the same amount, which is the speed of light.
Mark, you don't have to look further than the size of the visible universe to know that cosmologists believe in an epoch of inflation above the speed of light. There are more billions of light years from one side of the visible universe to the other than there are years available in modern cosmology. There hasn't been enough time.
There's a reason for that. the reason is because those stars, right, those stars which emitted the light used to be closer to us. And then they've moved. The universe has inflated. So the visible universe is like 46 billion years or so. But the whole point is that we're only seeing light from like the 14.6, the creation of the universe. The point is that since those stars emitted light, those stars have then moved further away. So we can see them and we can evaluate where they are. But we're seeing the stars as they were billions of years ago, which is the time it takes, I might add, for the light to travel to us. So that's the way it works. So I mean, I'm sorry to point out that you're, scientifically incorrect on this, but all of it pairs up with an old universe, old Earth. And, if you want to overturn physics, that's fine. Write a paper, get the calculations, submit your paper, overthrow Einstein, go for it, TRock. You're very
I'm not trying to overthrow physics or Einstein.
Yeah, you are.
I think you've just denied what the standard literature actually says about inflation and the speed of light, because presumably you don't think those stars moved at the speed of light or faster, at least not faster than the speed of light, right? You said that the light reaches us, but the stars
nothing moves faster than the speed of light. I mean, we've got particles up to 99% of the speed of light. We've got particles really close to the speed of light. We haven't exceeded it ever.
That space is, for all intent and purpose, geometrically flat, right?
Is this a flat Earth thing?
No. I'm not implying flat Earth. You're really bad about
that's a relief,
putting words into my mouth. No,
so that's
when I say spatially flat, what I mean is it's very how do they say it? Euclidean geometry. It's basically very three-dimensional. In other words, there's no real curvature to space like the Big Bang predicts there should be. It's very three-dimensional. In other words, if you had do straight up from here, because you see a star up from here, you can literally go in a hypothetically perfectly straight line to a star you see straight up, and you will get to that star. That's what it means. The universe is very three-dimensional in that respect. It does not have a fourth curvature dimension to it. So what that implies, though, I know you don't get it, but what that implies, though, is
I don't know what that's got to do with anything, to be honest with you.
That's why I'm explaining it to you. If you go one direction and you travel 14, the supposed age of the universe is 13.8 billion years, right? So that means that if you go 13.8 billion years or light years in one direction, nothing, per your comments, nothing has ever traveled faster than what we know as the speed of light. And then you go 13.8 billion years in the exact opposite direction, you have a net 27.6 billion light years distance between them. That's not enough time at strictly the speed of light to get that far apart. That's simple geometry on paper.
I have no idea what you're talking about, because the faster that you speed up, the slower that your time passes relative to the areas around you. So at the speed of light, those points will basically be at a standstill. This is what we know about mass as well, mass effect. Because what you're talking about with 3 dimensions, you've forgotten time. Time is a dimension of space. It's space-time. So the things that affect time are things like your relative speed to the speed of light, and mass affects time as well. So there are things that affect it. While time would be passing normally for you, on the other end, as soon as you get to the speed of light, it basically slows. And I don't know if we can get to the speed of light. As I've said, we've only managed to get 99% of the speed of light. So I'm really sorry, TRock, your understanding of physics, and I'm not a physicist, but they're worse than mine. And maybe we should wrap up there, because we've got onto an entirely different debate as well. But I'm really sorry, but nothing about that comports with physicists' understanding of space-time at all. I'm really sorry, mate.
TRock, save your rebuttal. If there's anything you want to say, save it for your closing statement. So excellent endurance from the both of you. When the 50 minutes came about, I was going to say this discussion was so good that I could listen to you both for another 50 minutes. And we got another 50 minutes out of you. So that's great. Probably one of the most comprehensive debates on this topic out there. Again, great endurance. That was, as I go shut off the timer here, exactly an hour and 41 minutes of nonstop discussion. We even got some discussion on distant starlight.
Age of the universe, yeah.
Age of the universe, age of the earth, a little bit of everything. So, okay, TRock and Mark, appreciate you guys. I advertise this as Clash of the Titans, and you did not disappoint. So appreciate it. And we still got some closing statements to get through before some audience questions. We got about 150 people in the live chat enjoying this Saturday night showdown. So we're going to hand it to Mark. Mark, you get the first 5 minutes. TRock, you'll get 5 minutes. Then we'll do some audience questions. So whenever you're ready, Mark, I'll set the timer and the floor is yours.
Yeah, so thank you very much. This debate was on the physical evidence for the age of the Earth, or the physical evidence on Earth's thing. And I've presented multiple physical evidences that all correlate with one another. They've been scientifically tested, scientifically proven, and we can determine this from the scientific literature that has conducted all of these experiments. There is no physical evidence that TRock has presented at all for a young Earth. All he's basically said is there's problems with this, there's problems with that aren't actually problems, that we're aware of some inconsistencies with dating methods, and therefore we put some reasonable expectations of error margins on them, but they still keep working out to be the same date. The reason why TRock is doing this is because he believes in a book and will take that over any scientific evidence presented. As I said in my opening, this young Earth creationism, I'm really sorry, it has the same level of scientific evidence as flat Earth. It does. And we've heard the same arguments I hear from flat earthers heard from TRock. Oh, it's your interpretation of the data. That's what flat earthers say. Oh, there's problems with the calculations that your, Nobel Prize winners are making. Yeah, we hear that from flat earthers as well. It's almost a mirror of the science denial and the looking for any excuse to make their hypothesis work. And I mean, TRock finished it all off by basically undermining one of the fundamental laws of the universe: nothing exceeds the speed of light. And, please check that in physics. Please do your own research, I guess. Find out if anything can exceed the speed of light. It can't. The whole idea that you have to find something wrong in physics for him to be wrong, no, there's nothing in physics that denies a flat Earth either. They just interpret the data how they want to interpret it. They do exactly the same as TRock's doing. They take the scientific evidence, interpret it in a different way to say, hey, gravity doesn't exist, or this doesn't exist. TRock thinks that radiometric dating is not the incredibly consistent and reliable method it is. He's interpreting the scientific data however he wants, but that's not how we find out if things are true or not. You could make a case for almost anything if you want to go back and interpret scientific data however you want. That's not how we find things out. That's not how we have progressed as a species, in humanity, in society. That is not how we've come so far. Everything has been due to scientific progress. So I really do encourage you to look into, if you're Christian, look into Christians doing scientific research, mainstream scientific research, not fringe groups like Creation Institute. Check out BioLogos. They're Christians. They do science. They're very good. I like them. But again, we haven't seen any evidence or any good evidence presented by TRock, just some hypotheticals that could possibly work because he needs them to work. Thank you.
Thank you, Mark, for that closing statement. And now we're going to hand it over to TRock. TRock, you have your 5-minute closing statement. Whenever you're ready, the floor is yours.
Okay, so Mark pretty much conceded the debate whenever he said no, young Earth interpretation does not imply a contradiction of physics. If it doesn't imply a contradiction of physics, than a standard physics explanation can explain the data in a 6,000 year time frame period. It literally, in order for the 6,000 year interpretation to be invalid, it has to be a contradiction of physics. If it's not, you don't have an argument that says that the physical evidence demands an ancient Earth, period. So case in point is the radiometric dating that's been talked about so much. My argument is that you don't know where primordial uranium, for example, just pick a parent radioisotope, it doesn't matter which one, but you don't know where they came from. And because you don't know where they came from, and you don't know what process formed them, the alternative isn't, and so the big question in radiometric dating is, how do you know that the sample that you trust your date assignment on, how do you know that it started with 0 daughter product? How do you know that? Well, the answer is you don't. The answer is that whatever process formed primordial parent isotope most likely formed daughter isotope at the same time. What happened? When the Big Bang expansion happened, did the parent go left and the daughter went right so that the two would never again meet, so that all we get today is the parent that has decayed to the daughter? And so that 100% of the daughter that we have is strictly from radiogenic decay? No, that's insanity. So there is nothing about physics that demands that you have to accept that all of these age assignments came from 100% radiogenic decay. That's just insanity. There's no logic to that whatsoever. On top of that, because it is extremely reasonable to assume that daughter isotopes are formed through the same processes that parent isotopes are formed. As a matter of fact, if you look at the periodic table of the elements, the daughter, of course, is always lighter than the parent. That's why it's decay. You're losing particles from the atom to produce a lighter isotope. The Big Bang supposedly starts out with hydrogen, helium, and trace amounts of lithium. Those are the very first 3 and the lightest elements on the periodic table. What that implies then is that, and I'm looking, I've got one on the wall, but I don't remember exactly which isotope is the first radioactive isotope on the element on the periodic table. But the point is that the gradient goes up, not down. In other words, heavier elements are formed from the bottom up, not the top down, like radiometric dating implies. They strongly imply that all their dating methods are valid and or can be corrected by basically mathematically removing so-called primordial daughter elements. All of that is insanity. An alternate explanation is that the daughter was formed at the same time the parent was. Whatever process did that formed them both. And the problem with that in the secular origin scheme is that now all of a sudden no radiometric dating method for deep time is valid. None of them. And that's the point. But that's why they reject that thinking, not because physics demands it. Physics does not demand that. On top of that, add to the fact that we've got a magnetic field that follows standard physics electromagnetic decay curve. And it's going back in time just a few thousand years, elevates the magnetic field strength way too high to support life on Earth. Thank you. And so the magnetic field decay rate is strong evidence that the Earth has not been around for billions of years. There is no mechanism that supports that, not the alleged dynamo mechanism either. The Earth is not a dynamo. I've already pointed this out. I think every geophysicist in the world knows this. The core is turning at the same angular velocity as the mantle and the crust. It's all moving at the same speed. That's the antithesis of a dynamo. The sun, on the other hand, has a so-called differentially rotating core, which means the core is going a different velocity than the outer shell is. But to put a finer point on it, Okay, velocity is a vector, meaning it has direction and magnitude. And in this case of the sun, both are different from the outer core, and you can have this dynamo effect in the sun, but you can't have it in the Earth.
Okay, TRock, thank you for that 5-minute concluding statement. And with those concluding statements, that concludes the debate. And now we've got an audience Q&A to enjoy with lots of excellent questions. Gentlemen, since we have basically just hit the 3-hour mark, again, great endurance from the both of you. Would you both like a couple minute, restroom break?
Oh, I'm
yes,
good.
I need to get a drink of water real quick, and I will be right back.
Okay, go ahead. Mark, you've evolved past the need to take breaks, so it's very impressive. Coffee and nothing more.
Yeah, so this has been a long one, I guess. I do apologize, but that's been really long.
No need to apologize. There's no better way to spend a Saturday night, and in your case, Mark, correct me if I'm wrong, a Sunday morning.
Sunday morning, yeah.
Sunday morning showdown for some, Saturday night showdown for others. So
yeah, absolutely. No, it's a great way to spend a Saturday, and great way to spend a Sunday. Absolutely. This has been a great debate. I've really enjoyed it. The time has flown by, I got to admit, but I am getting a little tired now. Most people don't understand how much sort of debating takes it out of you. You have to use your brain a lot, and I might get my wife to get me another coffee, actually, while I wait. Thank you, sweetie. She's wonderful. And I do want to thank you. I think I mentioned in my opening, I do want to say that you've been nothing but absolutely professional and courteous and a really good host. So I do want to say that. I've always had a very professional interaction with Donny, more than some other debate channels. I got to admit, I won't name names, but certainly more professional than others. But
well, I do appreciate the compliments and the kind words, Mark. You're always professional, and this debate specifically, as you've put it, 3 hours. I guess until you get into the world of debates, you don't realize just how quickly 3 hours can go by.
Oh,
and
yeah.
On a heavy topic like this, you almost need 3 hours just to, discuss each of the important points. So you and TRock, you guys made for a really professional debate, and I like that you guys came in swinging. You guys put in the work. And so I want to thank you both for that, especially if TRock is listening. For the audience sake, let me remind you. So we've been consistently doing about 4 to 5 debates a week. And typically we'll take Sundays off. So tomorrow we've got Sunday off. And my recommendation is if you're not caught up on this week worth of debates, please do check them out. We've had a good diversity of topics. And we will be back here, as a matter of fact, this week with a debate between Kent and Kennedy. And so, Mark, you kind of helped set this one up. So I want to thank you for that.
Yeah, no worries. He was very keen to debate, didn't know how to get started. I recommended your channel, and, he wanted to debate evolution. I'm like, well, Kent will debate anybody. He will actually debate anybody. So bring your best. And, he seems like a really nice guy. I had a long chat with him and a friend of his. He seems like a really nice guy. So
absolutely,
we'll see what he can do. Yeah.
So I appreciate that, and anybody who wants to debate the topic of evolution, yes, you know who to refer them to. And so we've got this one and his friend, as you've pointed out, Mark, Evan. So I've been talking. With
Evan's
Evan
gone as well. Fantastic. Yep. Yeah, oh, great.
We've got them both. So Evan and Kennedy, we've been chatting via email, and they are excited. And I'm excited to have them join the debate community here. And so hopefully this will be the first of many. So we've got those debates, and anybody who's in the chat, just make sure you're subscribed, because we do have debates on other topics as well. Monday, we're going to kick off the week with not a science-related debate, a debate on theology. So this one will be the Great Limited Atonement Debate. 2 seasoned debaters here, Dan Chapa and Turretin fans. So with that, TRock, good to have you back. And Mark, I guess we're just going to jump right into these questions. You're both seasoned. Oh, yeah.
I
go
just
ahead.
wanted to mention, I thought it was radium, the first one on the chart. I was wrong. I had to look it up. I wasn't sure. I thought it was radium. It's not. It's polonium. So that's the first radioactive element on the chart.
Okay, perfect.
Just FYI. I mean, yeah.
Thank you.
And TRock, as you were gone, getting a drink of water, I was just complimenting you both for, coming in swinging, but keeping it professional. I appreciate the way that you guys, make your points with no interruptions and just kind of go back and forth equally timed that way. So very enjoyable debate. I had a blast and the audience had a blast. And with that, I am going to put a timer in terms of the audience questions, because we've probably got enough questions. We could go for 4 hours. So I'll start the timer. We'll say no more than 30 minutes and we'll get through as many questions as we can. So with that, let's start basically at the beginning. So I haven't really had a chance to read through every single question in detail, so we'll work through them together. So here we go. First question comes in from Taylor K. And this question is for Mark. If the Earth is really billions of years old, why is there still helium found in rocks, given the current rate at that it leaks into the atmosphere? Let me say this before you answer, Mark. Given the comprehensive nature of the debate, a lot of these questions are probably going to pertain to topics you've already discussed during the discussion itself. So apologies ahead of time. Go ahead.
No problem. So helium does get trapped. That wouldn't account for the decay. However, what I first said was that uranium-238, as it decays, it releases an alpha particle, as do some other radioactive elements. Alpha particles are 2 protons, 2 neutrons. That is a helium nucleus. So element number 2 is helium. So that is why we still have helium, because it's been created by radioactive decay. Very, very slowly, I might add.
Okay, I appreciate it. TRock, if you'd like to add anything, go ahead.
Yeah, this is a great question. Again, it's super easy to go down these very long rabbit trails. But this is a really interesting one, because there should not be helium in those rocks, period, if the Earth is 4.5 billion years old. And the reason is because helium, being an inert gas and being very, very small, will slip through crystal lattice structure quite easily. And more specifically, it's temperature dependent. So the answer Mark gave is not actually an answer. It's yes, we know there's radioactive decay. We know that the decay rate is slow. The problem is that the escape rate of helium at the given temperatures are much faster than the rate of radioactive decay of the uranium. If it's faster, that means it cannot accumulate. That means that for any given atom of helium that is produced from an alpha particle is going to escape before the next one comes out, so to speak. It's not quite that cut and dry, but you get the idea. If ever so often an atom of helium is produced, the one before it has already escaped at the extremely slow rate. So the problem here is that where these samples were pulled, they were pulled, and I'm going to have to I'm kind of guessing a little bit. It's been a while. I've read the info. It's really interesting stuff, but I want to say it's in the range of 3,000 to 5,000 feet deep in the crust of the Earth, which is approaching a mile deep. The temperatures are way too high there. Mark made a comment during the debate, something about how I guess he was basically saying that Russell Humphrey's helium escape rates were off by orders of magnitude. No, the argument against Humphreys from the secular community was that he was not assigning the correct rates. What Humphreys actually did was get a secular science lab to measure those rates from an actual temperature range across a broad temperature range. The pre-existing scientific information in the literature did not do that. It extrapolated escape rates for given temperatures. It did not directly measure them. Humphreys had them directly measured, and they did come out different than the literature previously stated. But that was a big lesson learned for the secular science community. It was not an error on Humphrey's part. Bottom line is the helium escapes too fast under the given temperature conditions. And there is no way to justify a 1.5 or a 4.5 billion year timeline given the difference in those two rates.
Okay,
Yeah,
TRock.
just quickly, I didn't say that it was actually the diffusion of helium into zirconium that I talked about, but just totally off topic. Please, we are running out of helium. Please don't use helium balloons if you are concerned about the helium stocks in the Earth at the moment, because it is estimated that we will run out, and it's really useful substance for things like MRI and imaging. So please don't use up helium. Thank you.
Okay, thank you, Mark. And what we'll do for this Q&A, I think, as everybody knows, whoever the question's for, we'll just make sure they get the last word, and then we'll move along smoothly. So here we go. Next question comes in from Dave H. Dave, appreciate the question. Now we got a question for you, TRock. So we got a nice healthy mix, I believe, of questions for the both of you. He's asking, TRock, if you think that radiometric dating is flawed, why do scientists around the world build complex machines to date things? Why would they bother? Oh, TRock, I think you're on mute.
Thank you. To be specific, scientists don't build complex machines to date things. They build complex machines to count isotopes. That's what they're doing. They're interpreting them as dates. Is there a benefit to counting isotopes that has nothing whatsoever to do with a date assignment? Absolutely. It's how you determine what types of minerals exist in the world. What are you going to do with those minerals? Are you going to turn around and, material sciences are highly dependent on those sorts of things. So there is a benefit to understanding that it's not strictly done in the context of origins.
Okay, thank you, TRock. Mark, over to you.
No, I'm good. It's a good question.
Oh, okay. Let me just see. I want to try and go back and forth. One for Mark, one for TRock. So I'm just looking through these questions. See one for Mark. Okay, I see one for you here. Who, what, when? $10 super chat. Appreciate the support. And his question for you, Mark. Are there any actual scientists who disagree with an old Earth and an evolutionary premise?
Yeah, I mean, there are young Earth creationist scientists who do disagree, but that's sort of not how we evaluate what scientific consensus and current theory is. They also have been pointed out that, I mean, it's not like they're not actual scientists, it's just their methodology has been called into question in multiple papers that have come up about the experiments that they have done. So while their papers can't seem to pass peer review, which is being subjected to academia and everything they know to see if they have consistent and reliable results. So I'm more levering the idea that their methodology is not up to standard, not that they're not scientists at all. Some of them have worked on other things that they've been very successful at and done valuable research for. I'm not minimizing their achievements. I'm calling into question, as is the mainstream scientific consensus about the work they're doing on this particular subject.
Thank you very much, Mark. TRock, anything you'd like to add? Go ahead.
So yeah, it's a good question. It does kind of highlight a couple important points. One is that peer review is a horrible metric for determining whether a scientific writing or research of any kind belongs in the open literature. It's a horrible metric. Peer review has allowed more garbage into the open literature than you can shake a stick at. Having said that, the problem with all of origins science is that you cannot use one shred of it to develop real-time technology or medicine. This is always one of my biggest arguments against it. It's completely worth the tenets that are exclusive to deep time are completely irrelevant to technology and medicine both. You can't develop a pill that's going to cure you in 100,000 years. That's nonsense. You can't develop a cell phone that works on what the time is 3 billion light years from here. It's completely irrelevant. Deep time, again, those fundamentals that are exclusive to deep time have nothing whatsoever to do with technology and medicine, whereas the tenets that are exclusive to young Earth creation have everything to do with developing medicine and technology.
Mark, you get the last word.
Yeah. So, I mean, when it says nothing to do with it, the methodology is the same, or the scientific methods are the same. There's various different ones, but use the same sort of overview method in order to do it. So they do have something in common, and that's the way we've been able to advance all technology. Everything that we have, computers, phones, everything is part of that process. And I agree that peer review isn't perfect, but it's the best method that we have at the moment. Because if we're going to skip peer review, then we've got to publish flat earthers, we've got to publish psychics, we've got to publish, people who believe that fairies are at the bottom of their garden, as long as they write a paper about it. The whole idea is that we have to have some kind of process to eliminate results that have been collected incorrectly, things that have dubious scientific nature, and that's the process. And that's fine if you want to believe that that's not to your liking, but you can't sit here and say that that process isn't great, so just let me do anything I want. That's the process we have with science. And that's the process that has given us every single major technology that we use today. Sorry about that, but that's the truth.
Thank you for the final word there, Mark. And moving on to a question for TRock, coming in from Creationist Crybaby. So CC's coming at you, TRock, and he's asking, explain how several radiometric dating methods of meteorites and the oldest Earth rocks give ages over 4 billion years.
I think I've already fairly thoroughly explained this. Two alternatives exist. Either you assume that 100% of the daughter isotope came from radiometric decay, or you don't assume that and you don't have a dating method. They give these alleged ages of 4+ billion years because that's the ratios that they exist in. But that is still just question begging. You haven't explained how 100% of the daughter isotope came from radiometric decay. And I'm saying a far more logical explanation in standard physics is the process that created the parent isotope also created X amount of the daughter isotope at the same time.
Appreciate it, TRock. Mark, anything you'd like to add?
Yeah, so this is sort of just a wild speculation. We do see rocks form, like igneous rocks and metamorphic rocks. We have seen them form on Earth at much younger ages, so we can sort of evaluate how much of the parent element is in there. But you're saying, so T-Rock saying, well, there's more of the daughter element in there, but he hasn't got any basis for that. Things like potassium argon, as I pointed out, we know it contains no argon because argon's a gas. So our samples collected from the very deep inside, we know has to have come there through radioactive decay because argon does not appear like that in recent examples. So this whole idea, this premise that he's like, well, we don't know the daughter element. No, we kind of do. And that's just sort of science denial again by T-Rock.
Thank you, Mark. T-Rock, you get the last word. Question was for you.
Yeah, that was not science denial. What Mark described was the formation of an igneous rock, not the origin of the elements that comprise the igneous rock. Those are two different things. And so he's not really broached the subject of where did the elements, the first appearance of those elements come from. Nobody knows. It's entirely speculation how the Earth formed, and it defies physics anyway. You can't get a rocky body formed the way the Earth is by dust flying through outer space until it finally coalesces and a star explodes, and then you get star debris flying through space until finally enough of that collects around another star that hasn't yet exploded until it finally gravitationally collapses on itself and forms a planet. None of that is science. It's all 100% speculation. And as far as Mark's comments on the presence of or lack of argon in modern samples, no. Go get some modern igneous rocks that for example, in Hawaii, their volcano there, Iceland. Where am I thinking of? Is it Iceland? They had a volcanic activity here fairly recently. Anyway, go get any one of those recent deals. You'll find argon in the lava flows and in the ash. It'll be there. And that's been a main problem. One of the things that many modern or many 21st century scientists have done is ignored taking those control samples and looking for it. They've just assumed that argon escapes so quick that it can't be there except by radiometric decay. But modern volcanic activity shows the exact opposite.
Okay, thank you, TRock. Next question comes in from Carmine. And now it's for you, Mark. So thank you, Carmine, for the super chat and the question. Question for Mark. Was the singularity in space, or was space in the singularity?
Neither. The singularity was space. It was all of the universe. So this idea that the singularity was in something, or in something was in the singularity, that's not accurate at all. It's the singularity was the universe. So when you're saying, and it's space-time, not just space, neither was in either, they are the same thing. It's just that the singularity describes a state of space-time where everything is compressed into one very, very massive and localized area.
Appreciate it, Mark. TRock, anything you'd like to add?
Massive and localized area. Massive. Okay. Yeah. Now, what Mark described, the singularity, it's all mythological. Nobody's ever seen such a singularity. You can't measure it. You can assign whatever ghost physical properties or quantum mechanical properties you want to it, because it's entirely mythological. Singularities just don't exist. Somebody's got one. I'd love to see it.
Okay, thank you, TRock and Mark. If you wanted a final word, go ahead.
Yeah, so it's not mythological. It's basically science taking back from the expansion of the universe that we can prove with redshift, the way that galaxies are moving away from us. And if you extrapolate that back, it describes a very hot, dense state. Now, it is true that we can't see sort of into the singularity, because once you get to that point, the laws of physics kind of break down. But we can see up to one Planck length, which is a tiny, tiny amount of time after that singularity. So Big Bang Theory, while people think it sort of is there to explain the origins of the universe, it doesn't in reality. What it does is it explains the rapid expansion of the universe that we see. And all of this is science. It's not mythological. Mythology is a book where a god created water and then sort of used it somehow to magically create a magnetic field around Earth. That's mythology. You know, you can throw in the talking serpent and the talking donkey in there as well.
Okay, thank you, Mark. And next question is now for you, TRock, and this comes in from John Rapp. And John is asking you, how do you explain the hundreds of meters, up to 1,500 meters, of limestone deposits around the world in a young Earth creation time frame? And he says it would be impossible for that much biomass. Go ahead, TRock.
Yeah, not impossible at all. I've seen some very bogus calculations done to try and imply such things impossible for that much biomass. No. How do you get hundreds up to 1,500 meters of limestone? Well, the short answer is limestone's basically created in a number of ways. One of them is chemically. It can be produced chemically very rapidly, and it can also be created. Limestone can be created by basically pulverizing the hard shells of crustaceous animals. So the question is, it's not 100% in that answer. What you have to understand is that if you're calling the limestone itself a biomass, you're misunderstanding limestone formation, because it can be produced chemically. So you don't have to convert 100% of all limestone on Earth into some sort of pre-existing bioform. It's just not legitimate science. It would be much more accurate to assume that probably the majority of existing limestone comes from chemical processes, and the places where it's apparent that it's not all from chemical processes is where you see a lot of fossils embedded in it. in which case you can assume that it's probably a combination of chemical processes as well as pulverizing pre-existing living bioorganisms.
Okay, thank you, TRock. Mark, the floor is yours. If you had anything to add.
Yeah, so while it is true there's sort of chemical ways for limestone to form, the vast majority of it has been sort of calcium carbonate by organisms, shells and that kind of thing, which has created limestone. To do this volume of limestone, you would need millions, if not billions, of years of these organisms dying. The fact that it can form chemically is not what we see when we analyze these limestone deposits. We mostly see the calcinate carbonate from shells and other sort of sea creatures. There is no possible way that the amount of calcium carbonate we see could be deposited by creatures within a 6,000 or 10,000 year time scale. It is literally impossible. So it is a good question for the creationists to have that they don't seem to have an explanation for.
Thank you, Mark. TRock, question was for you. Get the last word.
Yeah. Again, just he's basically just throwing out there claims that are completely unfounded. When it comes to limestone and how many organisms it might take to create again, no scientist on the planet knows what percentage is chemically accounted for and what percentage is biologically accounted for. But what we do know is that what I know personally, because I saw a guy with a PhD do this, basically miscalculate and misrepresent this argument altogether. And how he did it was he said, okay, there's, what are the belemnids? Belemnids are basically the little tiny conical seashells that are akin to squid and, what's the other one? I apologize. I'm getting a little bit tired here, but anyway.
Cuttlefish?
Yeah, cuttlefish and other types of that type of creature that basically live inside conical shells like that. So thank you for that. But the point is that he made this long argument about how there are so many belemnids on the planet that the density of them is way too thick to account for in a 6,000 year time frame, just like Mark's doing here. Except the PhD that made this argument was actually has a PhD in biology of all things. The problem is that he did his math on a 2D surface, and so it wasn't a very PhD-like argument. Belemnids don't exist in a 2D surface; they exist in a 3D environment. And when you convert his numbers to a 3D environment, you find out that they occupy actually a very small percentage of the total ocean volume that's out there for them to live in. So no, those are completely empty claims that there are too many crustaceans in the fossil record to account for 6,000 years.
Okay, thank you for the final word there, TRock. Next question comes in from Stephen Tibbetts, and he's got a question for Mark. And so he's asking, if the universe stretched like a balloon, wouldn't things show a slightly curved path unless we were exactly at the center of the balloon? By the way, he says they made light go 300 times light speed, I'm guessing.
Yeah, okay. So the universe isn't like a balloon. I was just using that as an analogy to try and explain how expansion works, to try and explain that it's all points expanding at once. So the curvature of space-time, in a way that's very, very difficult to understand. If you did proceed in a straight line, it would curve back to where you started from. But that's just sort of Einstein's theory of relativity that sort of says that. It's very difficult. But space-time does curve. We know this because sort of the fabric of space-time, when you put a large enough mass, there is a curvature to it. That gravity is sort of the effect of space-time curving where everything falls into that curve. Time also slows because space-time, when you do curve space-time, it basically runs along a longer track to get to the same point. But yeah, I mean, talk to a physicist. I'm not aware of us accelerating light to 300 times the speed of light. Give me 1 second. I'll see if I can find that out. 300 times the speed of light. Yeah, I'd have to get a citation for that one, I'm afraid. If you could just cite me, that'd be great.
I appreciate that response, Stephen. If you are in the chat and you feel like you want to cite a source, I can certainly put that up. So, TRock, anything you'd like to add? Go ahead.
Yeah, I'm apologize to the questioner. I'm going to ignore the second piece of that altogether. I don't really follow those arguments too much, but for the main piece of the question there, wouldn't show a slightly curved path unless we were exactly at center of the moon. Well, and this is what I was saying earlier. The Big Bang predicts a fourth spatial dimension that doesn't exist. It's space itself is very three-dimensional, the same way we experience it right here on Earth on a very small scale. But it's not there. The Big Bang is pure mythology. It's the modern mythology. It should produce some curvature that is detectable across distances of space, but it's not. The only thing that is detectable, Mark alluded to, is that okay, you can see some gravitational lensing from very massive bodies like black holes, but that's not the same as a fourth curvature dimension to space.
Okay, TRock, appreciate it. Mark, to be fair, you can have the last word if you'd like to. Question was
I think I found it. So this is sort of gain-assisted superluminal light propagation. So while nothing can exceed the speed of light, space-time can do whatever it wants to. So, for instance, a theoretical wormhole where it's basically folding space round so that you're not traveling faster than the speed of light, but instead you're taking a shortcut, that is possible. However, you would have to propose the mechanism for doing that. As far as I understand it, the superluminal light propagation experiment used tunneling barriers and sort of gain lines to cause the light to reach there faster. That does not mean it traveled faster than light. That what you've got is sort of probably a media broadcast about the science without actually understanding what they actually did. So the light did not travel faster than the speed of light. Instead, they used shortcuts to make it reach the destination faster, but they didn't actually make it travel faster than the speed of light.
Okay, thank you, Mark. And looks like we've got, as we start to wrap up the Q&A, looks like we've got a couple questions that are directed at the both of you. So this one comes in from Nikola Edison, and he's got a question for the both of you. So he's asking, what do both of these gentlemen think about the ancient ruins found in Turkey that are said to be around 12,000 years old? I guess since Mark started with the last one, TRock, you can start with this one if you'd like to.
Okay. They're said to be around 12,000 years old, but are they? It's the same basic problem. One of the very fine points that creationists make, and no, this is not flat Earth conspiracy, and it is the reality of the way the world works. There are no absolute dating methods. Zero. Either you were there and you know when something happened, or you weren't and you don't, and you have to kind of guess or approximate. So the 12,000 year assignment that you're talking to, let's just say, I'm not familiar with the specific example, but let's say, for example, in this case, we're talking about carbon dating. So carbon-14 dating has a calibration curve to it. How is it calibrated? Well, in more modern times, it's fairly straightforward. If you find an axe handle that has a known age, you carbon date it and you adjust your carbon ratios to account for the age that you know the axe handle is. Go back further. It's not an axe handle anymore. Let's say it's a I don't know. Let's say it's some debris left behind in a jar of pottery, a pottery jar, for example. You're going to carbon date that. How do you know how old it is? how are you going to calibrate the carbon age you get from it? What you're going to do is you're going to use the archaeological context to produce the date and verify it against the carbon ratio, and then you're going to adjust the carbon to match the archaeological context, not the other way around. The further you go back in time, the more difficult that becomes, because you start, even archaeological contexts start to get really fuzzy. And so as carbon dating goes, once you get past about 3,000 years in the past, it starts getting fuzzy really fast. By the time you get 5,000 years, it can be outright difficult. By the time you get to 12,000 years, you're so far out beyond what people actually know that the 12,000 is a guess, and now you're using other means to calibrate. You're either using the short part of the timeline you do know and extrapolating out that far, or you're quote unquote cross confirming it against other methods, such as let's say carbon copper alloys and stuff like that. There's some isotopic evaluation that can be done to produce quote unquote ages. At that point, you're calibrating one rubber ruler against another. The stuff that is in Turkey is not 12,000 years old. If they're ancient ruins, it's guaranteed that they're less than 6,000 years old, and the calibration curves that are used are just flat out wrong.
Thank you, TRock. Mark, over to you.
Yeah, so this is sort of what is hailed as the world's first architecture, and the whole rubber ruler thing is a complete science denial by TRock. We don't just use one method like radiometric, we also use a variety of other methods to date it, and they all have to be cross-confirmed and things. So what we have here is basically TRock trotting out a whole massive, it's all a coincidence that these things came up with the same dates. It's all a coincidence that they all match up. Don't forget that potassium, argon, uranium can be used from 1,000 years onward. So there's no problem dating these under that method. It's just that anything under that, we get wildly inaccurate and inconsistent results. So there is a place for these dating methods, and they all seem to agree, which TRock sort of hand waves away and says, oh, well, your dating methods are inaccurate. But what he doesn't explain and fails completely to explain, and there's no physical evidence for, is why all of the dates match up with different evidences. He hasn't explained that. And yes, we can, get archaeologists to sort of estimate date ages of civilizations and things. That's what they do. So there's another field that TRock wants to wave away and say, hey, they can't possibly be right. And why? Because he has a religious belief. That is the only reason why. If there was no religious belief that he will believe over any physical evidence, he would not be hand waving it away. But that is what he believes. So the bias is clear. The correlation between these dating methods is clear. The correlation between archaeologists and architects and people that understand structure is clear. The ice cores are clear. All of this evidence is clear. And basically TRock will do anything to make excuses for all of them correlating to the same dating methods. There is no problem with dating this stuff. The only problem is in TRock's head.
Okay, Mark, thank you. And to the both of you, thanks for your responses. It was a question for the both of you, so we're going to move on. And I've got 2 super chat questions that just came in. So what we'll do is get through those. And then we're going to shut her down, as we're now at about 33 minutes in terms of the audience Q&A. So time flies by, I got to say. And I do want to thank the debaters tonight for their time for this debate that is going to be close to 4 hours. So here we go. Last 2 questions, the super chats. And it looks like they're both questions for you, TRock. So this one comes in from Ray AI. Thank you so much for the support and the question. So question for TRock. If the world is really young, why do most scientists reject your model if there's so much evidence for it as you claim? Why are the experts so anti-creation? Go ahead.
So that's a good question, and it's a fair question, to be sure. The reason they reject my model, and it's not my model, I just happen to strongly agree with it based on both the biblical and scientific principles. But the reason they reject my model is because before you can collect data and make it mean anything to you, you have to have a way of thinking about that data. In other words, Science is not this standalone, all-knowing entity that kind of sorts itself out over time. There's a philosophy behind it that exists before the science does. Somebody had to decide why it was necessary to collect data before they started collecting data. So it's much more of a philosophical question as to why they reject it. They reject it because when they, in modern science, and actually modern, I mean relative term, go back a couple hundred years ago, scientists had already decided they are going to reject any and all explanations that are not purely materialistic. Period. Once you do that, you've eliminated one of the logical possibilities to explain the data completely. So how is it going to come up on your radar, or how are you going to accept anything that violates that tenet of your science of philosophy?
Appreciated. TRock, Ray, again, thanks for the support. And Mark, anything you'd like to add?
Yeah, so thanks, Ray. Really appreciate it. The whole point is that we don't take biases into science, or we take as few biases as we possibly can. And TRock's basically outlining how basically the creationist scientists are taking their biases first and then going in to prove those biases correct, which is what we want to try and avoid. Now, don't forget that the age of the Earth wasn't always 4.5 billion years old. It wasn't always that number. I think that geologists sort of thought it was in the millions first off when they first started doing it, and sort of presented that. And that was accepted for a long while. As we have gotten better and better and better at our scientific knowledge, we have gotten more and more accurate at dating the Earth. But this is something that's been happening gradually. It's not like scientists just went, well, we're gonna decide that the age of the Earth is millions and then implemented that. No, it's always up for debate, absolutely. But you have to come without your religious bias, without your you have to have correct scientific dependable methods, and that is what the creationists are not doing. They're not anti-creation. The experts are anti-bad methodology.
Okay, thank you, Mark. And TRock, quick final word.
Yeah, thanks for that response, because it really kind of reminds me of the gist of this whole debate, because Mark brought this up earlier. Bad methodology. No, what it really boils down to is the methodology. There is not one methodology in science. There are actually two in secular science and one in creation science. The two in secular science, and it's why the ancient Earth and ancient universe origins model is so completely wrong, is because the method used in secular origins is one of pure extrapolation, and it's mutually exclusive to the method used in modern technological and medicinal development, which is interpolation. They're mutually exclusive. You cannot use interpolation on deep time origins studies, and you cannot use that type of extreme extrapolation in deep time origin studies in the development of modern technologies, material sciences, and medicine. They just don't work. You could never extrapolate orders of magnitude to that degree in order to produce a bridge, a cell phone, a cure for a disease, for example. It won't work. There are repercussions for doing such things. Instead, in the young Earth model, you use interpolation in origins and you use interpolation in modern scientific development. So why do most scientists reject my model? It's because they insist on extrapolating origins and interpolating modern technological development.
TRock,
contrary to common sense, by the way.
Okay, appreciate the final word. And here we go. We've made it to the end. This is the final question. Final super chat comes in from Lyle. Appreciate the support. Question for TRock. Do you accept age of the date given of the Dead Sea Scrolls and whatever method science used for this specific dating?
In short, I'll say by and large, yes, I do accept them. I'm not sure exactly what you're getting at. Are you saying, okay, there because, and I believe carbon C14 dating is what was used on the Dead Sea Scrolls. I could be wrong on that, but if you're implying that C14 dating is accurate in a YEC view for some things, then why isn't it accurate for all things? I've kind of alluded to some of this before, but you can't. The C14 method that was used was already calibrated against known standards, both before, during, and after the era of the Dead Sea Scrolls. So it falls inside of a well-documented, calibrated segment of C14 time extraction, and so it's going to be correct. And so specifically what that means is some sample that was known to be older than the Dead Sea Scrolls because it had a solid archaeological context to trace the age to, was dated, calibrated carbon-14 against that date, again correcting carbon-14 to the archaeology, not the other way around. Something that is younger than the Dead Sea Scrolls, known by an archaeological context, also calibrated against. Dead Sea Scrolls is right in between them. It's going to be correct because the corrections have already been made. But when you start talking about things that go beyond the scope of written history or a sound archaeological context, for example, you find bones in a cave, there's no real archaeological context to it unless tools exist with it, for example. And if tools exist, then you have to compare tools to some local community that supposedly existed around the same time, and then start forming it based on a proximity to the cave, not the cave itself. So again, you're talking about this long history of how dating methods are calibrated. And I'll reiterate this one more time. It's a rubber ruler when you get beyond written history, because yes, I'm well aware there are many methods for dating that are out there, but they're all calibrated against each other. If they're calibrated against each other and not an actual known standard like written archaeology, then you're guessing. That is literally all you're doing. So in short, yes, I'm happy to accept the ages assigned to the Dead Sea Scrolls based on interpolated data.
Thank you, TRock. Mark, over to you.
Yeah, and thank you, Lael. What an amazing question. Very amazing, I got to say. And yeah, sort of this shows the bias, because what we've got is that when it comes to scientific standards and the scientific dating provided by science for other things, it is, you can't tell the amount of carbon that was there, you've got it wrong, you can't tell, it's a rubber ruler, it's not accurate. Then when it comes to something that is in his worldview that he wants to believe, suddenly radiocarbon becomes incredibly accurate and can be relied on to date the Dead Sea Scrolls. It just shows the bias, because even though it was written history, we still don't know the amount of carbon that was there at the start. That's his argument. That's not mine. That's his. So for him to accept the dating method as accurate when it comes to certain things shows a cherry picking. It's accurate when it comes to my thing that I believe in, but it cannot be accurate for scientifically for the other things that we measure, like say, a temple 12,000 years old. Why is it that the Dead Sea Scrolls with carbon-14 we can measure perfectly accurate? For something that is 2,000 years old, but 12,000, no, it suddenly becomes inaccurate. It's because of bias. It is because that is the thing that he does not want to believe. There is no reason, and I think that the dating of the Dead Sea Scrolls is accurate as well, because I think carbon-14 is an accurate dating method. And the measurements is not measuring one against the other. It is measuring the decay of atoms, which is consistent. It's a consistent measurement. So, the whole idea that, and he's already admitted that to the half-lives of these elements. So he has already conceded that these decay rates are accurate. Why we can't use that to make accurate measurements, if A, the time is known, and B, we know them to be consistent, is beyond me. And it just shows that whenever something he wants to be true is measured, suddenly the methodology becomes perfectly accurate. This is the bias that we just cannot allow into science.
Thank you, Mark, for the response. TRock, you get the last word. Go ahead.
So Mark says he's perfectly fine with carbon-14 dating beyond, the 5,000 years that I'm alluding to. I'm going to suggest he's going to throw in his own bias whenever he wants to. Case in point is dino soft tissue. Go carbon date some dino soft tissue. If you find stretchy, spongy, elastic dino soft tissue, it's going to have carbon-14 in it. Is Mark going to accept the carbon age of a dinosaur soft tissue that can only go out to approximately 50,000 years or so? Absolutely not. Why not? Because his bias says that carbon-14 shouldn't be in there. And if it is, I'm willing to bet what he will fall back to is the same rescue device that most secular origins people fall back on. They're going to say contamination or background radiation or something to that effect, which is completely bogus. Can't be contamination in situ, because the thing that would get the contamination there would either fully permineralize the soft tissue so that it wouldn't be soft tissue anymore, or it would completely destroy it so that it wouldn't exist anymore. So the whole contamination thing doesn't work, and Mark doesn't agree with carbon-14 dating when it contradicts his presuppositions anyway. For me, I'm not inserting bias. What I'm doing is inserting good scientific common sense. Interpolate between known data points. That's the point. When you get to 12,000 years, you're not interpolating between known data points. You're extrapolating beyond the most distant data point you have, which is only around 5,000 years or so.
Schweitzer didn't find carbon-14 in that soft tissue sample.
Sorry, you don't get the last word on that. Sorry.
Yeah, convenient, hey?
Okay, guys, that wraps up the epic, nearly 4-hour debate on the age of the Earth. Feels like just a few minutes ago when we were chatting it up backstage, and here we go, 4 hours later. So congratulations to the both of you. I think this debate may just be the most comprehensive on these specific topics. So to the live chat, thanks for all the questions that came in. And really, we still could only get through a fraction of them, and that's about a 50-minute audience Q&A. So to the debaters, I got to thank you both for making a debate to remember. And, you know, if it wasn't for the generosity of the debaters on this channel that give us their time, we wouldn't have so many awesome debates. So with that, I want to give these gentlemen some final words and final thoughts. And why don't we start with you, Mark, since you're unmuted? Thanks for doing this. Yeah, go ahead.
Sure, no problem. Thank you so much, Johnny. Thank you, TRock, for being my interlocutor. I as I said, I really go visit my channel if you do want sort of science and a sort of thinking person's roam through the YouTube sphere. It's a lot of fun. I do some other streams. I do some sort of fun streams upon occasion. So come and check me out. Do drop a like and a subscribe for Donny. He certainly deserves it. And thank you for being here and listening to my case. Thank you very much. It's been a delight. Thank you, Donny.
My pleasure. Thanks for those final words, final thoughts. And yes, to the audience, if you like what you heard from Mark, you like what you heard from TRock, check the description box. You'll find the relevant links to where you can find more from these awesome debaters. So TRock, we'll hand it over to you. Thank you as well. Thanks for the time you've given to us for this 4-hour debate. Let's get some final words, final thoughts. Again, thanks for doing this.
Thank you, Mark, for joining the discussion. By and large, a good back and forth conversation, I think. A lot of rabbit trails to pursue, so maybe sometime in the future we can pick one of those rabbit trails as a sure. Specific avenue to focus on. That's tough. I'll be honest with you, that's really tough. The conversation turns so broad so quick that it's hard to narrow it down like that, but I'm happy to if it could be done. Thank you, Donny, for hosting us. You always put in a tremendous amount of work and put out a very, very professional looking product. So thank you for hosting us. And thank you to the audience for some really good questions. I really do appreciate the thoughtfulness and the insight that many of the questions provide. So I enjoyed the discussion and always happy to demonstrate that standard physics does apply in YEC.
Okay, TRock, thank you for the final words and final thoughts. Great final words from the both of you. And I know the chat was having a blast tonight. We had a great chat, ton of questions, very lively chat, as a matter of fact. And so if you enjoyed this debate between Mark and TRock as much as I did, gentlemen, you guys had a debate maybe going on a year now. I'm not sure, but you guys had a debate. I think it was the evidence for God. And so, TRock. Oh, I thought you were going to say something. You unmuted. Yeah. So if I'm not mistaken, you guys had a past debate. So if people want to check that out, please do. And we'll probably have a round 3 at some point in the future. So with that, I'm going to let these debaters get out of here. I appreciate their time. I'm going to stick around just for 5 minutes going over some announcements and some reminders. So with that, again, Mark and TRock, thanks so much. And we will talk to you soon.
Hey, it's Donnie, sorry, real quick. Thought I'd throw this out there. I noticed. Sorry, I apologize. I'm not trying to get weird or anything here. It's just that I did notice early in the program that Dr. Joel Duff was in the comment section there, and so I will offer an invitation to Dr. Joel Duff to do what Mark has done here and join the discussion live, not strictly from the comment section.
All right, I like that.
Some people like debating, some people don't. TRock, it's good that you offer the invite, but not everybody likes to. So,
I understand.
Get in the octagon with the with the people. But yeah, thank you so much, Donny.
All right, guys, some bonus features there. It's like a Marvel movie after credit scene, a challenge to Joel Duff. Okay, gentlemen, thanks again. Okay, there we go. Another one in the books, as I like to say. Doki Doki says bonus scene post credits. Yes. And you know what? Maybe we should make that a thing from now on for these Saturday night showdowns. I've been looking forward to this debate for quite a long time. TRock, Mark Reid, I believe they're both experienced debaters, great debaters, and they did not disappoint. This was comprehensive. We're going on about 4 hours. And another thing I appreciate about Mark and TRock is they come in swinging. They put in the work. They do some serious prep, you can tell. And, those are the best kinds of debates to moderate and host. They're the most rewatchable debates. And they're the kind of debates that you learn the most from as well, because critical thinking is important. And one way that we uphold critical thinking is by hosting so many of these awesome debates. And we want to get, debaters of different views into the debate octagon to hash out these differences and discuss these topics in a professional and sophisticated manner. And that's something TRock and Mark Reid have both done. I'm sure we'll get a round 3 at some point in the future. So what I want to remind everybody about, my brain's about to shut off too after 4 hours, but we've got tomorrow off and we'll be back Monday. So this one's going to be, what is the true meaning of 1 Timothy 4:10, the great limited atonement debate. So that brings to mind, for 2023, I'm now booking. I've basically got January fully booked. I've maybe got a couple spots open. And now I'm working to book debates for February and March. And January specifically, I should get them up on the channel sometime next week once I get the thumbnails in. And so we're going to have Paul Price. He's going to be jumping into the ring. He's going to be debating Snake Was Right in January on Evidence for God. Paul Price and I are also going to be doing a show specifically on Behemoth. So it's going to be titled, Addressing Liberal Scholarship on Behemoth. So that's going to be a lot of fun as well. I've also just booked another debate with Jamie from 215 Studio Official. He'll be debating Grayson. So that's coming up. We're going to have Nephilim Free. He's coming back for January. He's going to be debating Ryan Adler on Dinosaurs and Man. Did they coexist? We've also got, let me think what comes to mind. We've also got I'm keeping my thumbnail guy busy, put it that way. I've sent him a whole list of events for January. Pastor Chuck, who's been in the chat many times, he's going to be debating Steve Christie from the Born Again RN YouTube channel. They're going to be debating, do Orthodox Christians worship the saints and Mary? I believe that's the exact question they'll be debating. So that is going to be a lot of fun. And with that, I get a ton of requests almost every single day from potential debaters, those that haven't really entered the debate octagon, but they want to. And so my routine is typically, introduce myself. We'll have a little back and forth discussion. And then I will make sure to ask, what are their top 5 topics that they'd like to debate. And so I've got a good amount of people broken up into various lists, people that want to debate creation evolution, people that want to debate soteriology, people that want to debate, the Trinity. And so I've got a lot of potential debaters on specific topics. And so I'm looking specifically for people who are interested in debating for the pro-reformed side. Okay, so I've got a lot of potential debaters who want to debate against the Reformed side, specifically limited atonement. So if you're interested, you hold to the Calvinistic perspective, you could say, and you want to engage in debate, even if you're a first timer, reach out to me, send me an email, and we'll work on the details. Also, anybody for 2023, as we continue with the Evolution Debate Challenge series, if you're interested in debating the age of the earth, the global flood, evolution, typically the ones associated with our group that are always willing to debate. And so the young Earth creationists that are always willing to engage in the Evolution Debate Challenge series, Kent, obviously. So we're looking for more debates for Kent, Hovind for 2023, and TRock, myself, Professor David McQueen, and Nephilim free. So if you're interested, you're on the opposing side of, let's say, young Earth creation or separate ancestry, reach out. We want to make sure 2023 tops 2022. So reach out to me via email or just go to the website and click the contact section. Another topic as well. So we've got a big debate coming up. And it's an informal debate. The end of the month, January, this is going to be Dr. Stephen Boyce and Will Kinney, Bible translation discussion. So anybody who's interested in debating against the KJV only side, I've got a couple gentlemen, Will Kinney and Nick Sayers, that have informed me that they're essentially always willing to debate that topic. So I need more individuals who are willing to debate against the King James only side. Reach out to me and we can set you up for debates on that topic. We've got a debate first thing in January, Nick Sayers versus Turretin Fan. They're going to be debating the Bible translation issue. That's going to be a ton of fun. And also we've got this one I'm extremely pumped for. As everybody knows, I'm an eschatology geek. Okay, so I'm pumped. We had a debate last month, Pastor Matt First versus David Preston on who is Israel. That debate was excellent. Please do check it out. This one, Pastor Matt First, Pastor Daniel Eldridge, the great rapture debate. Is the pre-tribulation rapture biblical? They're going to be debating this topic, of course. So anybody who is of the pre-tribulation persuasion or of the dispensationalist persuasion, let me know. I'm looking for more people who are willing to debate that topic as well. So basically debating the pre-trib side. Okay, I've got Pastor Matt First, who's definitely looking for more debates as well. And so the more, the better on that topic. And Trinity versus oneness. That's another topic that I'm looking for more people to debate. So if you're interested in the pro-Trinity side, the pro-oneness side, reach out as well. And again, we'll have a back and forth, and I'll do my best to set you up with some debates. Okay, so real quick, I'm going to wind it down because let me see here. So next week, yes, we've got the limited atonement debate. Then we've got the is all life related through common ancestry debate with Kennedy and Kent. This one's going to be fun. And then we got the Christmas special, guys. So this is going to be awesome. We've done just a ton of shows with the creation research team. They're a huge blessing. A couple of my favorite, young Earth creationists. John Mackay and Joseph Hubbard. So we're going to be here. The Creator came for Christmas. Jesus in Genesis to Jesus in John. Very appropriate for the Christmas season. This will be on the 21st. And we've done a ton of shows with the creation research team. They're a huge blessing, and it's typically heavy on science. But this one's really just going to focus on, Jesus, who is Jesus, the nature of God, Jesus in the Old Testament, Jesus in the New Testament, just so many important topics pertaining to the, Christmas story, I guess you could say, the birth of Christ and so on. So that's going to be awesome. That's on the 21st. Okay. And then you'll notice there's a window on the channel from the 22nd to the 26th. Those 5 days, I've intentionally not booked anything. So that's technically going to be, as one could consider, the 5-day Christmas vacation, where we've got nothing within those days. Okay, nothing scheduled. And then the fun continues the 27th and on. Since it's basically been a nonstop year, debates, interviews, presentations, books. We've published several books this year. Over 50 debates alone in the Evolution Debate Challenge series. And conferences. We had our massive conference that was 5 days, 10 events. That was at the start of September, and we've basically just gone nonstop all year. So that's just going to be a 5-day window where it's kind of a breather. And that doesn't necessarily mean there's not going to be any content during those 5 days. I've started a series called The Case for Separate Ancestry. So if you haven't yet seen that, I just put it out last, I think two nights ago. And so during that 5-day window might give me an opportunity to do episode 2. I've also wanted to do some open mics or panel discussion. So who knows, I may be able to fit within that time period some kind of open mic on an interesting topic, maybe ancestry or eschatology. Who knows? We'll see how that plays out. And I think that's pretty much it that comes to mind. So I'll look at the chat real quick, and I think we're just going to wrap it up. We're just going to wind it down. So yeah, make sure you're here for next week, especially on the 21st. Make sure you're here for our Christmas special. It will be live. We'll be taking questions. We'll be engaging you guys in the chat and in the audience. Also, we did reschedule Professor David McQueen and also Ryan Adler. So we did an open mic discussion night last week with Professor David McQueen, and that was fun. Grayson joined. It was on Noah's Ark, the Genesis flood. So if you haven't yet seen that, please do check it out. We also just hit 12,000 subscribers. So that's awesome. It's been a great year. And if you're new to the channel and you love debates, then go to the playlist section. You can also find most of them on the website. Although it's always, I've got a website designer. So typically it's every month or so that I do update that. So this was actually our 257th debate on all sorts of topics. So you click this playlist, you can start from the beginning. Some of the classics from 4 years ago. I mean, look at some of these debates. Nephilim Free versus Donny Reid. Who would have thunk it? So go through these. And, the further you go down, the more recent you're going to find in terms of the debates. And you'll see kind of how the channel's evolved as well with the caliber of debates 4 years ago versus now. Okay, so nonetheless, you can check out this playlist and 257 debates. That'll keep you busy right up to the rapture, essentially. So with that, guys, thank you so much for tuning in. And I appreciate it, Michael. So we hit 12,000 subscribers this year. Let's try and hit 13 and then 20. We'll say 20,000 is the next goal. And okay, share this content around. Thanks for tuning in. And that's a wrap up. Standing for Truth is out. God bless all.